Hey, everybody. Welcome to Create DevOps. My name is Jay Gordon. Thank you so much for being part of this today. I really appreciate it. We've got a great setup today. Hey, Marcus.
Hey Jay, how's it going?
Yeah, I'm really glad to have you, Marcus. I'm going to see you a little later, all right? Hey, Steven, how are you today?
Doing all right, doing all right. And how about yourself, Jay? Great, good to
You
see you.
know, Thanks. I'm doing all right. I'm really glad that we're here and we're able to talk to everybody about these big ideas around DevOps. So why don't we bring up what we're going to be taking a look at just to get started so we can go ahead and set up the day. So
Sounds good.
welcome to MS Create DevOps.
Oh, it is great to be here. I'm really looking forward to the lineup that we have today.
Yeah, I am too. And we're going to go over all of that right now. We're going to bring up this. So let's take a look at what we've got going on today. Sound good?
Sounds good?
So obviously, it's me, it's Steven. I'm here out of Brooklyn, New York. Steven, where are you coming from today?
I am just outside of Milwaukee, Wisconsin.
Ah, very, very cool. Well, I'm a cloud advocate here at Microsoft. I spend a lot of my time talking about infrastructure, DevOps, and I really appreciate everybody coming today and being part. Steven, why don't you tell everybody a little bit about yourself?
Yeah, so I am also a cloud advocate. I am a principal cloud advocate, and right now I'm on the cloud native team, focusing on all sorts of fun cloud native stuff. But I have a broad background in the DevOps space, having spent time in both dev and operational roles. And I'm really looking forward to the content that we have today because I can't imagine something that is more transformative for an organization than when they embrace DevOps.
Absolutely. So, why don't we go ahead and talk a little bit about today's agenda? So, today we have an outstanding group of speakers from the DevOps community. Over the next few hours, we'll have discussions about important subjects to ensure your success in implementing DevOps for your organization. Stephen, would you like to give us a rundown of who's joining us today?
Yeah, I'll get us started here. So we've got a great keynote opener from Martin Woodward from GitHub, followed by April Edwards from Microsoft, who's going to talk about the importance of automation. Who
Then
else do we
we've
have?
got, yeah, we've also got Donovan Brown, who's going to probably one of the heroes of DevOps here at Microsoft. And he'll be giving us a conversation about some cloud native. After that, we'll welcome Kat Cosgrove of Pulumi on a chat about security's impact to DevOps.
Very important topic. Then you're up leading a panel on observability with Quintessence Anx of PagerDuty, Alex Hidalgo of Nobi9, April Edwards, and April Edwards from Microsoft.
Yep. And then we'll wrap up all of our talks by hearing from Quintessence once again in our closing keynote about the changes in DevOps now that the practice is over a decade old.
Oh man, I feel old.
Yeah, I understand. So let's talk a little bit also the fact that we're going to be having a workshop too.
Yes. So after these wonderful talks, stick around for a workshop where we tie a lot of these concepts together and we get together and deploy a Bicep template via GitHub Actions. Now we'll create a key vault to store some secrets and see it all come together as we build an Azure Azure Kubernetes service cluster. You can start prepping yourself now by heading over to the repository and using the template to get started. You can start there at aka.ms/devops/AKS to get started. But we're going to spend plenty of time there at the end, towards the end. So we'll
Absolutely.
see
We
you.
got about a good amount of time to spend working through our really great what I think is a great workshop that you can follow along. And if you want to, you could always go back to the YouTube video that we're going to have here. That you can always scroll back and forth and see specific stuff if you missed it. And to follow along with today's event, make sure you add at Microsoft Create and at Learn TV on Twitter. If you're adding to the conversation, please, please, please tag your posts with hashtag MS Create. You can use this QR code to get to the Twitter feed directly. Steve, you want to tell us a little bit about our code of conduct today?
Yes. Yep. So just a reminder for everyone, right? We do have a code of conduct for the event. If you have any issues, please let one of our moderators know or head over to aka.ms/create-devops for full contact details.
And when you complete today's workshop, you'll be eligible to receive these special Azure Hero badges. These are blockchain based and a rare digital collectible. I know everybody's really into those nowadays. You can go to aka.ms/azure.heroes for a full description. So these are unique, and these are for completing today's workshop. And another great part, Stephen, is this plant a flag campaign, or I should say plant a tree. Excuse me, plant a tree to fight climate change campaign.
Yes, definitely. So if you stick around and complete that workshop with us, we'll plant a tree in your name. I think that's pretty cool.
Yeah, me too. I really think that it's important that we consider the environment and have a green contribution to this world. So we're going to make sure that you get a tree in your name. You'll get a digital sticker to those who complete the workshop at the end of the event. Really, really great stuff. I want to thank Suzanne for putting that together for us. Thank you so much, Suzanne. We really appreciate all the hard work you've done to get this all together.
All right,
so,
Jay, so
Stephen, I think it's now. Go ahead.
Yeah, I was going to say, I think we need to get moving along here. We've got, I think we just need to level set real quick on DevOps, and then we can get to Martin. I'm really looking forward to talking to Martin. So, I think he's got some good stuff to share with us.
So let's get started then. We'll start by defining exactly what DevOps is, at least the way Microsoft interprets it. And I think this quote by Donovan really puts it nicely. DevOps is the union of people, process, and products to enable continuous delivery of value to your end users.
Yep, pretty much sums it up, right? And it's not a myth, right? There are real business impacts. There are impacts to your technical team, and there's impacts to your business. And we see that borne out year over year through the work that Dora's done, through other studies that have happened, through the McKinsey Enterprise DevOps study. So really, I mean, what does this all mean, Jay?
Well, it boils down to that DevOps implementation helps organizations grow by placing a greater focus on delivering value, eliminating waste, streamlining the internal feedback loop, and always improving our products. So by utilizing DevOps methods, we will deliver our software faster, which will lead to happier customers.
Great. So we've identified these 5 big pillars of our DevOps success. And so we've shaped today's program around them. We have culture, automation, cloud native, security, and observability. But I think we're ready to get started hearing from our speakers now. So let's bring out our first presenter. And now that we've kind of outlined the event and we've set a baseline on what DevOps means, let's dig deeper into the DevOps experience with one of my favorite humans, Martin Woodward. While I primarily come from an operations background, Martin comes from a developer background, and that sets us up well to have this DevOps culture conversation and talk about breaking down the walls between developer and operators. So welcome, Martin.
Thanks for having me. Am I the culture then? Is that what it is? I just saw you had this in. Am I culture order? Is that who I am?
Yeah, you're culture.
Oh my goodness me. Well, there we go. First time I've ever been described as that's for sure.
All right. So Martin, how would you personally define DevOps, and what do you think that feels like in action?
Yeah, I mean, obviously Donovan's definition is great about bringing people, processes, and products together. It's important to emphasize it's not about products. Quite often DevOps is what the vendor's trying to sell you, sort of thing, but it's not. It's about the culture, it's about the processes, it's about supporting the people, and people first, as Donovan has it, because that's always the hardest part. Get the culture right, get the organization right, and then create processes to support those people. And the product side, the technology side is kind of easier, really. You can get products from everywhere. You get products from Microsoft, you get products from GitHub, you get products all around, and technology all around. It's the people and the processes to support those people. It's always the hardest. Patrick Dubois actually kind of summed it up well for me. He was saying that DevOps is whatever you do to bridge the friction created by silos, and all the rest is just engineering. And I really like that as kind of like a more pithier explanation of it. You know what I mean? It's whatever it takes to break down these silos and to get things moving and focusing on your customers. The way I describe it to a lot of my teams is like, if it hurts, do it again. If it hurts, just get better at it until it stops hurting, and keep does it still hurt? Keep punching yourself in the head. Okay, I'm going to get better at it until it stops hurting, and I'm going to have appropriate safeguards, and that's what it was. But that's not what DevOps feels like as a team. You did ask me that as well.
No.
It doesn't feel like continuously punching yourself in the head, but yeah.
Well, some days.
Well, maybe. Yeah, I mean, when you feel like doing it when you're on call, sometimes that's for sure. For me, it's all about the customer focus. I don't know if that's the same in a lot of the places that you've been working at, but having that strong, passionate focus on the customer, and that's what you're doing it for. You're delivering value for your end users. Doing it iteratively, continuously improving, but making sure you develop a safe place for all of your teams to experiment and try things. So that's incredibly important, and that also means you want to be investing in kind of automation to make quick iterations, because you want to be iterating quickly. Make that safe. It's no good just shipping things really quickly if you break things really quickly. You need to be able to do it safe. You need to be in a safe place, both culturally in terms of sort of psychological safety, but also safe places in terms of automated protections from doing the stupid things that we always do, especially when it's 3 a.m. and all that sort of stuff.
And doesn't some of that kind of fall out from that customer focus, right? Like, we don't want to ship our customers things that don't work, right? And so being able to deploy safely, having engineers who are happy, who are not burned out from being on call, they tend to deliver better things for our customers. So that customer focus, you asked it, if that was kind of things I saw as well, and most definitely, because a lot of these other things fall out from wanting to do the right thing for our customer. Yeah,
and it's very easy to say, isn't it? It's very easy to say, oh yeah, we're going to be customer focused and we're going to do this, but it's actually constantly working on breaking down those silos and doing it in an iterative way is the key, I think. Don't try and boil the ocean at once. Don't try and develop everything, because you're never going to get there. So just try, do a little bit, and then use data. Look and see, measure if you've done something, if you've made improvements, and then move on. Oftentimes when I have that conversation with teams, how are we going to measure if we've got better or not? And you get like and that's a great question, because it's like, why are we here? What are we doing? Like, what does success look like? And by focusing on those things continuously and thinking, it really helps you sort of develop and have a sort of more high performing team, I think.
Yeah. And does capturing some of that data and keeping that focus on the customer experience help break down some of the silos? Because you have to talk to some other people because you don't control the whole customer experience. Or is there a way that you try to share some of that expertise across your teams or systems?
Yeah, I mean, the classic one is like, you and me, you have more of an ops background, I have more of a dev background. And quite often when I go into a company and they're like just starting to sort of think about DevOps, they'll go, well, I've got like 3 DBAs and 300 developers, Does that mean I need a DBA per team? Does that mean I need an SRE and an ops person per feature crew, per agile team? And obviously, you can't have like infinite numbers of people. You can't do that. You can't, it would be great, but no. And so you have to figure out ways that you can kind of share that expertise amongst your team, you're never going to have enough people. So how can we build processes? How can we build practices in place that allow the individuals on the team who have expertise to share it with the rest of their team, but the whole organization? And that's not just ops and dev, that's like designers. How do you create a design system that allows your developers, allows everybody on the team to do stuff that doesn't look really ugly and is consistent and is consistent across the board? How do you make sure your technical writers are able to help influence the documentation and make sure that it's written in an understandable way by humans without having like 10 tech writers per team, and it's all that sort of stuff, and figuring out how to scale. That's definitely one of the challenges, and kind of one of the ways you've got to think about everything you do. How can I maximize? And I have a finite number of keystrokes in my fingers. I have a finite number of breaths in my body. How can I maximize those to have bigger impact by helping everybody on the team learn the things I know and work in a safe way and use my expertise to make it safe for them to do deployments?
So Martin, we've only got a few more minutes left.
Yeah.
What's one piece of advice that you would give to the folks at home who really want to start with DevOps?
Oh, I think for me, it's, obviously like listen to the talks today, and like pick one thing. What one thing are you going to pick from today that you're going to use and take back into your team next week? And you're going to use it, and you're going to try and improve that one thing just a little bit. It's that whole, do something that hurts until it stops hurting. So what are you going to take from today? What are you going to learn and like apply just a little bit of? Don't fix everything. Just improve it just a tiny little bit. And if you improve a tiny little thing once a week, you build the muscles of improvement. You build the ability to be able to change things, and you get better at change, and you get better at improving and improving the engineering systems. And all of those incremental improvements really start to add up. Do one a week, and you just start to pay down technical debt, and then start to move on and have an amazing engineering system that you're proud of, and that people want to work in, and that your team could be productive in.
Awesome. I love that focus on kind of iteratively improving. And, in the concept of iteratively improving, let's bring Jay back and iteratively improve our group here.
Well, I hope I'm an improvement so far. That was really great, guys. I really enjoyed listening to what your take is on DevOps culture. And I always believe this, Martin, and you can probably agree with the sentiment that if you're going to implement change in an organization, you better wear a helmet, because you're going to run into some walls.
Yep.
Or you're just going to keep punching yourself in the head repeatedly, but yeah, you definitely have to. You have to make it a safe place for people to do that. It has to be both psychologically safe and also safe in terms of processes to like make sure people can't accidentally cut the fingers off or whatever,
Absolutely.
Yep. It can be a painful journey, but it's a worthwhile journey. And that's one of the things that has come up in a number of conversations, right? Is like, hey, we're doing this DevOps thing, but it hurts. Yeah, some of these things are going to hurt because we're changing the way we behaved.
Very, very cool. So, Stephen, that was a great way to get started. I think Martin, Martin's one of the best people that I know who really advocates upon DevOps. I actually remember upon the Azure DevOps product launch, him spending so much time out there and getting that information into people's hands. I remember he had a push to deploy physical button that I really, really liked. It was an IoT device that if you hit it, it went ahead and kicked off a deployment through Azure DevOps. So we've got another speaker coming up in just a minute. Stephen, I want everybody to remember that their participation is huge. So
yes.
There's the chat where you can leave comments. It's native in your things like YouTube, or you can use the Learn TV chat. All of that, you can go ahead, put in your questions, your comments, keep your eyes open. We've got moderators. We've got people to take care of all that when you send in your questions, and we'll try to get to as many of them as possible.
Definitely. Please ask your questions. You got your people here to answer them.
So coming up next, who do we have? We have April Edwards. And April Edwards, you know what? I am so thankful that you're here today. You are one of my teammates. We're on the same team together. We
We
get to
are.
spend a lot of time learning about DevOps and really selling how important it is. So how are you today?
I'm doing great, Jay. I'm doing great. How are you? I'm so glad to be here. This is great.
You know, I'm doing well. Let's take a look at what you're going to be talking about today really quick. I know we've got a quick description that we're going to be implementing an automated process that leads to DevOps success. So we're going to go ahead and give you a chance to talk about automation on Azure. I think that you've got a lot of great information for us today, and I'm going to kind of let you take the lead. Now, I'll see where we go and maybe ask some questions along the way.
Sounds good. So we're going to talk about automation on Azure, and Martin Woodward just said it, pick something that hurts and start there. And before we start, we're going to talk about, why automation is important and what we can do to automate. So, we defined what DevOps is, right? And, it is the combination of people, process, and products and that technology thing to deliver this value. And we want to deliver value. We want to bring people together and we want to have common shared goals. And that's really important. And we need to increase the collaboration. And when you have different backgrounds in an organization, that can be really tough to do. Martin has that developer background and Stephen has that operational background. And same with you and I, like we have very different backgrounds, right? So we work together, you and I, in our organizations to execute these things, and technology is a big part of that, but it's driving that value of whatever we're doing. But we need to be able to enable our teams to do more and be more effective. And we need to facilitate experimentation in our organizations, and that's crucial. And we need to focus on automation. And, it's a hard thing knowing where to start, but we go, well, why is this important? Because, I'm an operational person. I don't want to change, but we need to make these changes because your competition's already doing it. And, forget everything else, forget all the stats about, increased velocity and all these things. Those are really important, but human error. A lot of the outages that you and I have seen and probably created ourselves has been down to our own error. So I want to talk about the people side of it a little bit. People is the hardest part of DevOps. We're asking people to make a cultural change. Now, when you have an ops team and a development team and any other teams in an organization and they're trying to make changes, traditionally we worked in silos and we blame that other side of the team. And that's difficult because, we need to be able to work effectively, but what we found is just blame the other side and we just toss things over the fence to each other. And that doesn't go well. That's not driving the same value together. So we need to look at, our process a little bit. We have kind of 4 phases in our process. And when Martin and Stephen and yourself were talking about DevOps, this is crucial because we want to continuously reiterate our process. Now, and that starts with the planning phase. We want to do everything early and often, and we want to fail fast. So when we talk about automation, if it doesn't work, we need to find something that works better or another way to do things. And when we're in that planning phase, we need to look at some of the tooling, whether we're using something like Azure Boards or GitHub Issues, etc., and plan what our work's going to be. We need to then develop our work. Whether you're in operations or a developer, yes, operations, you need to do some development work. And when we start talking about some things we're going to talk about in a minute, you'll understand why. And you may use tooling like Visual Studio Code or GitHub Codespaces, whatever your tool of choice is to develop. And then we deliver that code, and then we want to operationalize whatever it is we're delivering. And that's crucial to have this full cycle. So when Martin and Stephen were talking about the process and we talk about DevOps and we're going to start automating things, we want everything in this process to be fully automated when and where possible. But if we make one change today, and like Martin said, one change per week, we can start building on top of our process. So I want us to focus on tooling over tasks. Now, Jay, with an operational background, when you were taught to automate something, how did that make you feel?
You know what? Automation to me really made me feel like we were taking the manual work out of our hands and really placing it into, in a way, in another basket. We were still working on how to actually create automation. We were testing it, making sure that every single time we had notifications that said this deployment has occurred, and it gave me a little bit of safety.
And I think that's awesome. But I think we see a lot of people that are really afraid of automation. And I think we need to think of the tooling side of it, where we need to let our machines do the repetitive tasks while our humans are building the tools to solve the problems, and we're being more proactive, right? And there's a massive value when we start to automate things. And I'm going to quote one of my favorite humans, Jeffrey Snover. And he said this, and this is so true from when I've engaged with operational teams across the world and development teams as well. Nothing is more important than automation, because productivity equals career security. So when people are in maybe an operational role, we see it a lot where we're afraid to automate something because it takes something out of our hands, out of that control, but then allows us to do something more proactive. And we look at all these issues in our organization. So we have automation to the rescue. So we talked about that process before. And we're going to start looking at how we can automate our builds and do things early and often. So we do building of our code, and we start testing our code, and then we start deploying it. And you go, well, hold on a second. That's great for developers, but I'm in operations. So I want to talk about infrastructure as code a bit, because it is part of DevOps. And when we start talking about this whole process and we start automating these things into what we're deploying, we're kind of referring to what we call continuous integration and continuous delivery. And there's lots of tooling out there that can help us. I want to talk about infrastructure as code because, Jay, both you and I love infrastructure as code. It's kind of at the heart and soul of what we do, right?
Yes, and there's so many different options out there nowadays. I remember coming into it, and it was pretty much Chef and Puppet, and those were and then there was like CF Engine and things like that came as well.
I grew up in a PowerShell world. I say grew up. I mean, in the kind of the automation side of my career, it was all PowerShell for me. That's where I learned automation. I started automating things in Exchange and SharePoint and through Windows Server many, many years ago. And I didn't think of it this way, and it took some time, but infrastructure is code at this point. And when we start looking at tooling like infrastructure as code to start automating the beginning process, and this is great because this is something you can do on premise, you can do it in Azure or multiple cloud. And we start looking at different practices, and this is where the tooling side comes into play, but this is also the people change. And I know, Jay, you and I can attest, we have to change a lot to embrace these processes, right? Mm-hmm. We have to start putting our code in code source repositories. So maybe we're using GitHub or Azure repos. Then we have to start looking at the life cycle of our code. And this has a lot of benefits because we start not just hoarding our code to ourselves and then, something going awry when we go on vacation, but we start collaborating with our teammates. So that breaks down those barriers. So we start collaborating with our other operational folk, our developers, our DBAs, our PMs, whomever else is involved in that project. So we increase our collaboration. Then we start versioning our code. Think of it, the old days where we kind of save a file and go, you'd have like file -1 and different versions. You'd put it into like your little file server. When we start using, source code repositories, we start using better practices where we version it, and we can also have governance around it, and we can have full traceability. And this means we can also have our code as reproducible and very scalable. And that's what customers want. They don't want to just go deploy a virtual machine and be done with it. So the types of tooling with infrastructure code is vast, and people go, where do we start? There's tons of options. So the first few at the top are are Azure native. So we have ARM templates, but Jay, you and I have both used, right?
Mm-hmm. And now there's Bicep.
Yeah. And I love Bicep. I was not a fan of ARM, but you could go into the Azure portal, deploy something, export an ARM template, and get started. Like, it was a really good Azure native way to get started. Bicep, the overlay on top of ARM, is so much easier to learn, so much more readable, and it's gaining huge amounts of popularity. And then you can do stuff in the Azure CLI and with PowerShell. And now PowerShell is cross-platform. It's just not in Windows anymore, which I think makes it even cooler. And then we have the other tools like Terraform, which is multi-cloud. So again, for those of you working in kind of this hybrid environment, whether you're going Azure, AWS, or GCP, I want you to use Azure, but you can use Terraform. You also have tools like Pulumi that allow you to take the code knowledge you already have. Maybe you code in C# or Go or TypeScript. Pulumi allows you to do that and then write your tests in code. And then, like you mentioned, Jay, like Chef, that's a lot of what we got started with. And you have Puppet and Ansible, again, multi-cloud. State management of your environment. So this is kind of an end-to-end solution where we have this full cycle, where we plan in Azure boards as an engineer, and I'm using the term engineer to talk about our role effectively. Then we write our code in Visual Studio Code, accessing an Azure repo. We deploy that code to something, and then we wrap around that operational side with some kind of monitoring, like Azure Application Insights. Now, if everyone stays tuned for the next talk, we're going to hear from my colleague, Donovan Brown, where he's going to talk about a step further, where he's going to go cloud native and that full life cycle. So before we go any further, I love doing a demo, Jay. So are you ready?
I love me a demo. Why don't you bring it on up?
Cool. So I'm going to work in PowerShell because I love working in PowerShell. I've already pre-authenticated into the Azure CLI, but what I've done here is I've told Azure I want to deploy an Azure static web app. So I want to go full end-to-end, fully automated solution. So instead of going into the portal, we are going to touch the portal, but we're not going to deploy via the portal. We're going to use some, very light infrastructure as code. I'm going to connect this into I've told my code where my GitHub repo is sitting, what branch, where I want to deploy the static web app to, and the name of my static web app. So if you can see the name at the top, create DevOps. I'm sorry, that's the resource group. It'll be SWA-create DevOps. Now, when I run this code, it's going to go connect to my Azure portal. It's already authenticated through with Active Directory, and it successfully deployed my static web app. So I'm going to go over to the Azure portal, and in the portal here, I can see in my resource group, I have a new static web app. It's deployed much, much faster than if I do it from the portal. It also outputs a URL for us. Now, this URL is randomized. We can put in a custom DNS name. Absolutely, that's fine. But it spits that out on the creation of our static web app. Now, after it's created the URL, we can click on it, and we can see that our static web app is live, but there is nothing running in it. So, okay, we need to put some code in it. If we go back to our portal, we can see that it sees our main branch, it sees our GitHub repository, and it sees the action, and it's creating a workflow. So if I click on this edit workflow, what it's doing is creating a whole workflow for us. Now, this is awesome. So what we have here is a full CI/CD pipeline. So that is as soon as I initiate my code, it's going to execute this workflow for us using a GitHub action.
So it's writing all the YAML for us, right?
Yes, because when we talk about where do we start, what do we do? Like sometimes it's hard to know where to get started. And that's why I love Azure Static Web Apps, because as we deploy it from our GitHub repository, it gives us this YAML file. So we have CI/CD out of the box. So in this YAML file, it's going to say on any push of our code to our main branch, or maybe even a pull request, it's going to run a couple jobs. It's actually running two jobs. First, it's doing a build and deploy job. It's building our code. It's going to push that code out to our Azure Static Web App. And you can see here, on lines 25 and 26, it already kind of encodes our secrets for us. So it doesn't expose anything. It has that security built in automatically. So I don't have to think about it. So I want to actually go see this workflow run. So we didn't have any code into our website. I can see it build and deploy our code. It's still running. It's running through that exact workflow that I just showed you. So that's pretty cool. So now that it's completed successfully, I can go up to our static web app. I can go ahead and refresh the screen. Boom, we have a working website. How cool is that?
Wow. That's so great. So let me ask you a question about this. Do you think I should keep my infrastructure code the same repository as my application code? So like if I'm creating a Bicep template or something like that? So
I personally, and this is best practice, your infrastructure has dependencies on your application code most often than not, right? So they should be in the same repository. They should be in a different file structure as such, so they're maybe not next to each other, and they can be easily identified. You can put different CI pipelines to them, and you can cause different triggers, but they should be in the same repository. So you can do dependencies in your workflows and your branching policies. But yes, I've always put my source code next to my infrastructure as code. So in this instance, I could have deployed this with an Azure Bicep file. I could have used ARM. I could have used Terraform. I chose the Azure CLI just for a bit of visibility, but I could have this even more automated down the road. And I'd absolutely put this into another folder within the same repository.
Yeah, that makes a lot of sense because we want to make sure that we're checking in everything. We're looking at everything. We're not giving ourselves multiple pipelines because we can create, like, say, submodules of a pipeline. But, we don't necessarily need to have it in two completely separate pipelines. And, Donovan, who we'll be seeing next, was someone who kind of told me about how this is just a really, really cool thing to do, is to think about how you're deploying all of your infrastructure, not just bits and pieces and then your application deploy.
Absolutely. And that's super critical. And I want to go ahead and show you a little bit of an Easter egg that's built in this static web app. So if I go back to my static web app, I can go into my code. Now, my code is sitting in the same repository. I can create another folder. I am going to change my code on my main branch. Now, when I go into this file here, this is my website file. So, there can be debate on how this is done, but for just ease of display today, I want to go ahead and change this website on the fly. So we've just deployed our website. I'm going to go ahead and put in a welcome to create DevOps, and I'm going to go ahead and commit my code, but I'm not going to commit it to my main branch because that's bad developer practices. I'm going to get a pull request and create a new branch, which I can do within GitHub. I can also do that for my favorite IDE. And when it creates the pull request, it's going to run through our code again, because we have to remember those two triggers we saw in our CI/CD pipeline are going on pull requests or any change to main. And we can see here with change to website, it says number 16. Now, number 16 is the number of our pull request. So hang on a minute, because that's going to come back to us in a second, and we're going to show how that flows through in the process. So because I've opened this pull request, I've made changes to our code, we can go ahead and build and deploy our code again. It's going to run through that exact same pipeline. Again, this is all out of the box. So it's going to run through our code, do all this cool stuff. So we've created an Azure static web app. We've deployed our code to our web app without having to touch any quote infrastructure. It's all been automated end to end. We could go a little bit further and automate the infrastructure as code piece, but for now, we're going to get the website up. So
Very
when this
cool.
actually, yeah. So, but here's an Easter egg. Now, this is a special feature that is built explicitly into GitHub when you deploy an Azure static web app. So thinking of another developer best practice, we don't want to touch production, do we, Jay?
No, we want to make sure that we have some sort of place to go and stage.
Exactly. So in GitHub, we can see here, it creates a staging site when I open this pull request. So we can see it's here, it's ready. It does this automatically, and it's built-in feature. So if I click on this link here, it's going to open up our new version of our website.
Very cool. So April, we've only got about 2 minutes left or so, and I just wanted to say thank you so much. We've really learned a ton in just a short amount of time. And if people want to be able to reach out to you to talk more about this, right below, you can see that we've got April's Twitter right there, so that you can go ahead, reach out to her and ask any additional questions. We've got lots and lots of information also in the chat. We'll answer your questions. We've got some great ones that have come in. But anything, April, I want to just wrap up by asking you this. How did you really feel when DevOps first became kind of like a part of what you do? Just in like 30 seconds.
I had this idea that we could do things better. Like our processes could be improved, and I didn't realize there was a word for it. That was how new I was to it. So when I actually learned it was a thing, and there were stats, and there was like a process and a whole school of thought and like hard facts behind it, that really excited me. And that's why I went from an ops side to a developer side in my career. And that's why I became just enthralled with DevOps, how it works and how we can do everything better.
Awesome. Well, thank you so much, April. And you know what we've got next? We've got a session, and we're going to be talking about cloud native services and how we can deploy applications with those cloud native services. And we've been really lucky. We've got Donovan Brown with us today. Really a great producer, or I say a producer of content. He always comes with some of the most concise and really thoughtful presentations. And today is no different. So Steven's going to be in the chat answering any of your questions, but we're going to learn a little bit about how Helm can work with your deployments when you're creating your containers, and say something like Kubernetes to really simplify it. So we're going to be talking about templates. We're going to be talking about cloud native services and how they all can kind of come together to help you do your deployments. So we're going to get started on that in just a second. And I just want to remind you that you can send your questions in the native chat window. If you're using YouTube, we're happy to get your questions there. And also all on Learn TV. So aka.ms/LearnTV. Make sure you're tagging your questions on Twitter with hashtag MSCreate. And more than anything, let's just keep things rolling. So we're going to go over to Donovan right now.
Hey everyone, I'm Donovan Brown. Today, we're going to be talking about how adopting a microservice architecture will impact development and deployment. No matter what industry we are in, writing software has common patterns. We reduce costs by only using the resources we need and scaling out when additional resources are required. Applications are being broken down into units of functionality, each exposed as a service. We want to focus on adding business value and not managing infrastructure, so we leverage serverless platforms and use DevOps best practices. And the number of programming languages seems to never stop growing, and we should use the best language for the task at hand. On the surface, microservice development seems simple. It's a micro or small service, not a giant scary monolith. However, there are limited tools and runtimes to support distributed development, and many of the frameworks are tightly coupled to a language or development stack. A typical microservice might look like this: several small, purpose-built services all talking to each other. Some of the services also talk to external resources that store state or ingest events. Getting an application like this up and running and keeping it running has proven to be challenging. To address these challenges, the cloud native community has developed Dapper and Helm. Dapper is a set of building blocks to ease distributed application development, and Helm helps package and distribute these applications when deploying to Kubernetes. The goals of Dapper are to take years of experience and best practices and make them easy to use from any language and on any stack. It is driven by standards and provides a consistent, portable, and open API that can be extended and used in any cloud and on the edge. The goals of Helm are to manage the complexity of Kubernetes deployments by supporting easy updates, rollbacks, and sharing with a great templating feature. Both Dapper and Helm are community-driven and completely vendor-neutral. Before we can deploy an app with Helm, we have to build it. So let's first focus on Dapper. At its core, Dapper is a set of building blocks, including service-to-service invocation, state management, pub/sub, bindings, and secret management, with the support for actor model and observability out of the box. We can use as much or as little as we like. If we have already solved service-to-service invocation, but need help with state management, we can just use the state management building block. Or if we are starting from scratch, we can use it all, allowing us to focus on adding business value. Any language that can send an HTTP or gRPC request can use these building blocks. Not only can applications that leverage Dapper use any language, they can be run on any infrastructure. Dapper is implemented using a common sidecar pattern, where a second process runs alongside our main application. The main application uses HTTP or gRPC to call into the Dapper sidecar to take advantage of the desired building block. Here's an example application with two services, A and B. Notice each of them also has the Dapper sidecar. When service A wants to call service B, Dapper does all the hard work of discovering where service B is and securing the communication between the services. This slide also shows the pluggability of the component model. Without having to change our code, we can change where state is stored, where events are published, where secrets are stored, and even where telemetry is sent. When developing locally, we can use a Redis container and swap that out when we move to our cloud platform of choice. Let's use service-to-service invocation and observability as example Dapper building blocks. When one service wants to call another service, it must know the address, port, and number of instances of that service running. The service could be running anywhere. With a post request, we can ask Dapper to invoke the new order method on service A, and Dapper takes care of the rest. Observability gives us tracing across all the services in our application. With Dapper, we can configure what we want to see and where the telemetry is sent. This slide shows the same information visualized from Application Insights and Zipkin. As a developer, we don't have to write any special code. By running our application with Dapper, we get this for free. What I'd like to do now is a demo showing how to get started with Dapper. First, I want to show you the docs site at docs.dapper.io so you know how to get started. Simply click Getting Started and then click Install the Dapper CLI. This page will show you instructions for installing on macOS, Windows, and Linux. Now that you know how to get started, let's see some code. I'm going to switch over to Visual Studio Code where I'm inside an empty folder. To get started, we're going to create a new web API using the .NET New command. What's cool is we can Dapperize an application without changing a single line of code. We can start to use Dapper immediately by running our application with Dapper. With this command, we are giving the service a name, telling Dapper what port the app runs on, what port we want to access Dapper on, and how to start our application. Dapper will build and start our application and then launch the sidecar and wire everything up. Switching to a web browser, we can still access the application on port 5000. This allows us to incrementally adopt Dapper because all existing clients can still access the application on its original port. The real power starts when we have a client that uses Dapper to access the service. If we access the service via Dapper, the results are the same. But notice, we are now using Dapper on port 3500. This will never change, even if we change the address of the backing service or the number of instances. This is saying, hey Dapper, we need you to do something for us. We don't know the address of the other application. We don't know where it is on the network. We don't even know how many instances there are. But we know its name is my app, and we need you to go invoke the weather forecast method. Dapper locates my app and securely calls the weather forecast method for us. But wait, there's more. Because we're using Dapper, we are getting observability for free. Switching over to Zipkin, we can query all the telemetry Dapper was automatically collecting for us. We can see when calls were made, how long they took, and what services were involved. We can drill in and see detailed information. Without Dapper, we would have to write code to get this information. This information is invaluable when you need to debug a problem, and we get it for free by just running our application with Dapper. Now I'm going to stop the application and return to the slides to discuss more building blocks. That was just a quick look at getting started with Dapper. There is a lot more that Dapper can do, but I want to switch over to Helm and discuss deployment. Once you have Dapperized your application, it is time to deploy it. Helm allows you to organize and parameterize all the YAML needed to deploy your application. This makes it great for adding to CI/CD pipelines. A Helm chart is a specific folder structure that defines the details, values, and templates to be used to deploy your application. They can be stored in source control with your application or stored and downloaded from a registry. One of the benefits of microservices is that they can be deployed individually without disturbing the entire system. With Helm, you can create a chart for each individual service and deploy them when ready. You can also define dependencies between charts. This enables you to create a main chart that might deploy the entire solution in cases of disaster recovery or standing up temporary test environments. Let's switch over and see Helm in action and see how to use it with Dapper and GitHub Actions. Let's see just how quickly we can create and install a Helm chart and learn how to deploy it in a CI/CD pipeline. To get started, use the Helm create command and provide a name for the chart. Helm will create a folder with that name and populate it with a default chart. Before we dive into the details of the chart, let's install it. To install a chart, use the Helm install command. Provide a name for the release and the location of the chart. This will install the chart and display information on how to use the installed application. I will copy the commands now, but before I execute them, I will run the Helm list command. This will return the releases in the cluster, and there is the release we just installed. I will paste the commands I copied earlier. Once the commands are complete, I can browse to port 8080 and see the application running. Instead of creating a chart, you can download pre-packaged charts and install those the same way. But to use Helm to install your own applications, this is typically the way you will begin. Now that we have a working chart, we can take a closer look and understand how we would update these files to deploy our own services. First, let's review charts.yaml. This file defines the name, description, and version of the chart. Also in the root folder is the values.yaml file that holds any default values you want to use in the YAML files in the templates folder. The files in the templates folder will look familiar to anyone that has deployed code using kubectl before. Helm places all the YAML files in the templates folder and allows you to define placeholders that can be overridden with values from the values.yaml file or user-provided values from the command line. You would copy the YAML files that define your application into this folder and parameterize any values you will need to provide during installation. To learn more about creating Helm charts, you can visit my YouTube channel. With a basic understanding of a Helm chart, let's see how to use it in a CI/CD pipeline. The Helm chart can be checked into source control alongside the application it deploys. These files can then be used in your CI/CD pipeline to deploy your application into Kubernetes. Here's an example YAML file that uses GitHub Actions. To use Dapper and Helm, you need to install the CLIs onto the runner. Both Dapper and Helm have official GitHub Actions in the GitHub Marketplace. With the CLIs installed, the pipeline can now issue commands to both Dapper and Helm. I also take the chart and I update any dependencies and store the chart as an artifact of this stage of my pipeline. During the deployment stage, the chart is downloaded and Helm is used to upgrade the chart to the Kubernetes cluster. I hope I have piqued your interest in Dapper and Helm. These are two great tools to help you as you start to develop microservice applications. Be sure and visit dapper.io and helm.sh for more information. You can also reach out to me on Twitter, where I share lots of information about technology and answer questions. And visit my YouTube channel, where I dive deeper on both tools. I want to thank you for spending this time with me, and I look forward to seeing what you build.
Oh man, it's always great seeing Donovan, and I love how he always takes the things he's working on and finds a way to get them into a CI/CD pipeline.
Yeah, what did Damien, our former teammate, once say, and a member of that league, is like, friends don't let friends right-click to deploy. So it's always right-click
so
publish.
Friends don't let friends right-click publish. Yep.
Yeah, and so we're always trying to put as much automation in our process as possible. So I got a question for you, Stephen, that came from the audience. Is what would you say is a defining feature of a cloud native service?
Yeah, so it's actually a really good question. And in the docs, we actually have a full doc kind of explaining out what cloud native is. So to condense it down into what is kind of what is most or a short description of what cloud native is. To me, it comes down to it really embraces the cloud model, right? That it takes advantage of PaaS services. It can take advantage. It takes advantage of some of the portability concepts that we have. Easy to update different parts of your application infrastructure. You can go down the whole 12-factor route. There's a lot of different nuance that you can have to it. But to me, it's really an application that embraces that. Just embraces the essence of cloud and the idea that what infrastructure is there now might not be there later, and so we need to make sure that we account for that in our application architecture.
Absolutely, and somebody else wants to know, and I think I can start picking away at this one too, is they want to know if they can migrate to these cloud services or should they rebuild their application. And I think that really depends on one, your level of skill around that cloud native application, and secondly, what your capability of your development team is. You don't necessarily need to rebuild, but you may have to do some refactoring about how applications connect to one another if you're going into like a microservice environment. And that's what's great about something like Dapper is Dapper helps move you forward with using the that type of environment. And when you're also talking about cloud native services, you're also talking about pieces like auto scaling, using integrated services within these platforms as a service, like an AKS or even an app service. You want to be able to consider how they'll all work together, and and of course put that all into your pipeline. So I think that you don't necessarily need to move directly to. You can take off bits and pieces. You can walk slowly before you start running with using them.
Yeah, and the Azure DevOps story is actually a really good example of how do I take a legacy style application that was boxed software that was sold on premises, and how do I convert that into a cloud service? And a lot of the core is was that kind of central monolithic app, and then they started peeling out microservices as they needed to evolve them, right? So you don't have to do it all at once either. It's not an all or nothing choice. You can
Absolutely.
You can take this in bite-sized chunks, and in keeping with the capacity that your team has, and grow your experience as you do these little bits of work.
Well, speaking of bite-sized chunks, we've got to take another bite out of our session and head to our next speaker, someone that I think is just wonderful, someone that I'm really lucky I've become friendly with over the years, and just, aces all across the board. It's Kat Cosgrove from Pulumi. Hey, Kat, why don't you come on in?
Hello. Good morning / afternoon. It's morning here.
Welcome.
Well, Kat, I know we've got a lot to talk about when it comes to security, the importance of security. And I really just wanted to start by saying thanks for being part of this today.
Yeah, happy to. Thanks for having me. It's I don't think I've ever been in an official Microsoft thing before, so that's pretty cool.
Well, you're here, and that's all that matters. So, Kat, I know you've got some stuff to show us.
And some stuff crashing. I can fix that while I talk.
Sure. I know you've got some stuff to show us today. I believe you got a little mini presentation. Am I right?
I do.
Great. We'll be bringing that up in just a second. But first and foremost, Kat, I know you're from Pulumi, and automation, just like we've been talking about, is a big part of that.
Yes. I don't like having to do a lot of things manually. If there is a conceivable way to automate something out of my personal responsibility, I think that is my job to automate myself out of menial tasks. It's one, because I don't want to do these things over and over again. It's boring. And two, I say this in like virtually every talk I give, some of them more than once, but humans are actually really, really bad at repetitive tasks. It turns out it's extremely easy for a human to have a bad day or make a mistake or forget something. And also we're super, super slow compared to a computer. With automation, you can like iterate on the testing or whatever involved in making sure that an automated task is completed successfully and correctly in a consistent, reproducible way. With people, you can't really iterate on that. We're unpredictable, and there's nothing you can do to prevent somebody from having a bad day. Like that's not something you can plan for. So I think it's always safer to automate things where you can, and also it makes your employees happier when they don't have to do the same thing over and over again.
And so I think we're going to talk a little bit about security and how actually security fits into that story.
Yep.
Because as you're moving along in your software development release cycle, you don't necessarily want to think about security as a secondary thought.
Correct. Yeah, you don't. It should be a primary thought the whole time. I have a rant
Oh boy.
in my talk. So you'll get to hear me kind of ramble about that a little bit. I have even called the talk a rant. So I guess I'll just go for it.
Let's hear what you have to say, Kat. I am thrilled to hear you rant. It's something that I've always enjoyed.
Oh, I know you love listening to me not shut up. I cannot help but run my mouth. So hopefully this is entertaining for all of the people watching who I assume are on like Twitter and LinkedIn and everywhere else that y'all stream this. But
absolutely.
Yeah. Okay. I will go a ranting then. So y'all, today I'm going to rant about DevOps. I am also going to rant about buzzwords, just like a little bit. And I'm going to rant about security and maybe a little bit about the future. But before I start, here's a photo of me with my cat. Her name is Espresso, and she may or may not show up while I'm talking. She's actually in my lap right now. That's the best way to keep her quiet. I will not apologize for it if she yells because this is her house and we're in her living room right now. If you want to get a hold of me later, that's pretty easy to do. I am on Twitter at Dixie3Flatline, and Jay will be watching in the chat to forward on any questions, comments, complaints, compliments on my excellent sense of personal style or my bad Blink-182 t-shirt that you may have. Anyway, let's go. So first, I want to talk about the title of this session. It involves the term shift left. This is not a term I like, partially because it sounds like a buzzword, and I'm kind of allergic to those. Partially because I don't think that's actually what we want to do with security. We throw this term around like security only exists at like the far end of the software development lifecycle, and nobody ever thinks about it until then. And like we now want to pick up the entire concept of security and drop it earlier in the software development lifecycle. But I don't agree. I don't think that's what we actually want to do. I don't think that's what we're actually doing. What we want to do is distribute it throughout the software development lifecycle. First, I want to make sure that everybody is on the same page here. This is a DevOps thing, so I know that I can probably assume that you all know what that means, but to err on the side of safety, this is the definition of DevOps that I'm going to run with for the rest of this talk. DevOps is the term for the union of the development team and the IT operations team through the use of a specific set of practices and tool chains with the ultimate goal of shortening the software development lifecycle and delivering more high quality software. Okay. I'm defining that because I would rather not guess that everybody watching this is already an expert. So in order for DevOps to work, it requires tools and a culture shift. It's not something that you can just say you're going to do. This is a well-established fact. It's still the topic of a lot of really long conference talks about DevOps, even though DevOps has been a thing for about a decade now. I'm not going to go into this a ton because much more qualified people than me give outstanding talks on this very subject, and you should absolutely go listen to them. Probably somebody else has done it today. But to give context within the scope of this specific talk, DevOps may mean changing the way you write software. Your code needs to be written in a way that's more modular, and that makes it easier for other people to maintain it because ultimately people are the ones maintaining your code. It matters. And you need to merge with source often and pull from main often. Make much smaller changes every single time. Run build and unit tests with every single commit if you can. And that process has to be automated. Nobody is doing that manually. Nobody wants to do that manually. That's like That's an enormous potential problem. If an entire team does this, you end up with conflicts less often, problems are discovered way earlier, so hopefully you can fix them immediately. The idea here is that nobody exists in a silo anymore, at least developers don't, and operations teams don't. Everyone is like doing DevOps to some degree at this point. And this is a cultural shift that can take some getting used to, but you're going to be more efficient and you're going to be less stressed out. And we've mostly handled this with developers and operations teams. We're still kind of having some growing pains though. So you might be asking, Kat, where is security in this equation? The answer is it should be everywhere. It's not, but it should be. Your developers should care about security. Your ops teams should care about security. Your security team, which should still exist because distributing security across your entire SDLC doesn't mean like you don't have a dedicated security team anymore. Obviously, they will still care about security. DevOps is about efficiency, and we have tools now to bring security into the rest of your DevOps pipeline. There's more vulnerability detection and security automation tools out there than I really know what to do with or care to enumerate here. It depends on what kind of application you're building and where you're deploying it. Is it cloud native or not? There is some kind of tool for you. Really, there are a lot of them, and you should probably be using a couple of them. But that doesn't eliminate the need for a security team, and it isn't picking up the entire concept of application security and moving it leftwards towards the devs. It's supplemental. This allows your developers and your ops people to help your security team by distributing the workload and catching some problems earlier. So you might be thinking, what about DevSecOps? The introduction of the idea of shifting security left gave birth to this term, DevSecOps. Some people that I deeply love and respect use this term, to be clear. But to me, it's unnecessary. I am not really a fan of it. So earlier in this talk, I defined DevOps, right? I said DevOps is the term for the union of the development team and the IT operations team through the use of a specific set of practices and tool chains with the ultimate goal of shortening the software development lifecycle and delivering more high quality software. Fewer security issues and incidents is part of delivering more high quality software. It is. Security is not a late stage addendum to DevOps. It's belonged there the whole time. It's natural. We should have always been doing this instead of kind of just getting around to it now and putting a buzzword on it. So if security is a natural part of DevOps and everyone has to do DevOps to some degree to make the whole thing work, doesn't that mean we all have to do security? I think yes, and that's not shifting left. That's distributing it. Everyone involved in the development of a piece of software has obligations to the user, and the users expect to not have their personal information exposed or their devices hijacked or whatever. We're all doing security here. Some of us just don't know it yet. And I'm not saying that all of the developers on a team have to become security experts overnight, or all of your ops people have to become security experts overnight. I'm saying that there are some best practices that exist for your stack, for your tool chain, for your environment. And if we want to make this work better, if we want to make this easier, if we want to make these things more commonly automated, then it's important that everybody on your team is aware of security best practices specific to their role. And again, this isn't replacing a security team. This is just shifting some of their load throughout the rest of the SDLC. It's not picking up security and dropping it at the beginning. It's handing some of that work off some of the work that's easier to automate through using code scanning or vulnerability detection, or if you're in cloud native, some kind of like container tooling to make sure that there's nothing nefarious going on inside of your containers. There are things you can do to make this easier. On the part of your ops team, it's best practices around networking and like cluster permissions and on and on and on. These should never be falling to like a single employee or a single team. We should all be doing this, or it's not DevOps. We're just doing DevOps but keeping security in a silo. That sucks. That's not very helpful or efficient, and it's not what we wanted when we decided DevOps was a thing at DevOps Days Ghent 10 years ago. So that's the end of my rant. If you have any questions for me, I can take some of them now. If you would like to get a hold of me later, you can do that on Twitter at Dixie3Flatline. I do answer questions there. You can also try emailing me at kat@pulumi.com, but I'm going to warn you, I do not answer my emails with any degree of urgency. So expect that to be like way slower than
well, Kat, I will do my best not to email you. I don't want to get more email into your email box. I'm sure that there's lots and lots of things in your inbox that you will get to eventually. And of course, Twitter handles are right here on the bottom of our little chat or windows, so you can head over there. So I got a question for you, Kat. I want to talk for a second about the tooling around security.
Sure.
And is there tooling to best ensure I'm implementing the best possible strategy for security in, say, like my older apps?
I don't think that there is any one tool that exists that makes sure that you're in a best case scenario security wise for like all applications. It's like security best practices are an it depends situation. And so I don't think it's really possible to build a tool that covers all of the bases for all of the different ways you could build an application, all the different languages you could use, all of the different places you could deploy it. So I don't think there's a one size fits all. Certainly there are tools you can use to try to mitigate some problems.
Yeah, I know like OWASP is a big tool for scanning code, and there's a number of different open source projects and obviously paid projects that you can implement as part of that strategy to shift left, if you will. And I know you hate that term, but I think about it.
There are things you can use to like kind of get there, but you should never actually assume that your application is secure, because you can't predict the future. You can't predict what an attacker is going to do. You can't predict what vulnerabilities will be discovered and disclosed later on. Mm-hmm. I know, Espresso. She's mad. But we can certainly try. There are vulnerability detection and code scanning tools, both free and open source, that will help you out. Which ones I recommend depends on like how you're building an application. Frankly, that's it. There are so many of them that honestly, I would just be Googling it for a specific situation. It's really outrageous how many of these tools there are now. And
there are big like services that can be implemented as well. Like one of the things that a lot of people rely on are web application firewalls, WAF, to be able to sit in front of your application to add just another level of secure, because ultimately your security posture in your organization, it needs to be strengthened. And the way that you do that is by utilizing the tools that are out there, and also by considering it at the beginning of the process. So one of the great things that I know people do is they implement testing practices that include security.
Yes.
That they're doing audits, and not just audits for compliance reasons, but because they care enough about their application and code to run audits regularly.
Yeah, and if you're using some kind of like vulnerability detection tool, some kind of code scanning tool, that should be included in your CI. So like if a problem is detected, the build should be bounced. Like that is automating something easy out of your hands so that you don't have to worry about it. Your security team doesn't have to worry about it. Ops team doesn't have to worry about it. It gets bounced back to the devs and they address whatever vulnerability was found, which is usually just like an outdated dependency or something. So you just bump the version of the dependency if there is a fixed version, or you reassess whether or not like that particular vulnerability is one that you want to freak out about and hold up a build over. But yeah, there are ways to build this into your pipeline so that you don't really have to think about it. And it's just one less thing on your actual security team's plate to like have to deal with.
Absolutely. And so, Kat, I want to just wrap up this little session here with you and I. I know that we've covered a lot of stuff, but I wanted to ask you because, you're doing a lot of really cool stuff over there at Pulumi. I know you just had a conference, am I right? Where you can you talk just a second about what you did and people, if they want to watch the recordings, where they can go?
Yeah, sure. So Pulumi hosted the Cloud Engineering Summit yesterday, which was a free virtual conference for cloud engineers, all about engineering for the cloud. This was not, to be clear, a like Pulumi specific conference. We were just organizing it. So there were people talking about, CloudFormation and Terraform and whatever else there too. But I was the host for the build track. We had a lot of really incredible speakers, including we had Chris Nova talking about infrastructure as software. Her talk was incredible. We had Liz Fong Jones on my track talking about what open telemetry is. We had Heidi Waterhouse talking about accessibility. And it was incredible. All of the talks are already online, free on YouTube. So if you just go to cloudengineeringsummit.com, you can get to the talks from there. But they're all free and there to view online. We had Emily Freeman and like Kelsey Highwater. I don't know how we managed to put together a lineup that good. But
well, it sounds really, really solid. I know yourself and Maddie Stratton over there at Pulumi are doing a lot of great work to help everybody kind of automate their infrastructure and really get the right stuff done. That takes that manual work out of your entire process
with minimal effort.
Yeah, absolutely. So, Kat, I want to say thank you so much.
Thank you.
No problem. It's great to always get a chance to talk with you. And I really look forward to seeing what you're up to next.
Yeah.
Any place we should keep our eyes open at?
If I do something spicy, it'll always end up on my Twitter account.
Fair enough. Well, thanks, Kat. Thank you very much for being here today. All right. Well, that was Kat Cosgrove over from Pulumi. Just a wonderful person to speak with. And we also got to hear from Espresso the cat, who had a lot to say, but I don't think was overwhelming. We just got the right amount of information from Espresso. And so coming up next, we've got a really great panel. And the next one of the pillars that we kind of wanted to chat about today, that we feel will set you up for DevOps success, is observability. And so observability kind of differs from traditional monitoring. And we've put so much time and effort when it comes to ops into monitoring. But as applications grow, as environments change, we need to think about different ways to keep an eye on what is going to potentially happen in our infrastructure. And so I've got three great people to be part of this. It's Alex Hidalgo, who is Director of SRE over at Nobi9. We've got Quintessence Angst, who's a developer advocate with PagerDuty. Well, I know I'm too familiar with PagerDuty.
Everybody is.
Yes. And we're going to bring back April April, who is a part of our Microsoft infrastructure and DevOps team, where we talk a lot about these concepts. And so I wanted to first start out and give everybody just a chance to briefly introduce themselves, at least Alex and Quintessence. Alex, why don't you give me the quick executive summary?
Yeah. Hi, everyone. My name is Alex Hidalgo. I'm the Director of Site Reliability Engineering at Noble9 and author of the SLO book. I've been a site reliability engineer for 12 years now, I believe. And it's really kind of, a profession that really lines up with my personality. And over that time, my primary interests have really always been incident command and observability. So I'm very happy to be here today.
Awesome. Thank you so much, Alex. And I really do appreciate you being here. And Quintessence is next. Hi, Quintessence. Thank you so much for being part of this. Why don't you give me that executive summary as well?
Executive summary. So I am currently a developer advocate at PagerDuty. I got here by way of a very circuitous path in tech that included tech support in a hardware lab, database administration, cloud engineering, infrastructure engineering, and whatever, as I just kind of meandered my way for about a decade throughout, located near Niagara Falls. So if y'all ever want to take a nice trip out and see something really cool, we do have an amazing waterfall. You might have heard of it.
And I know you've been involved in the DevOps Days community, taking part in DevOps Days Buffalo, being part of that team of people that really bring that event together and serving that Western New York area. And now, because of virtual conferences, the world.
Well, we did last week at a drive-in.
Wow.
We figured that it started as a joke, but then it was like in our January meeting to plan for October. Vaccines weren't out, right? And we're like, how do we commit to a venue without committing to a venue was the problem to solve. And then it was like, oh, if there's a vaccine or masking or loose requirements or strict requirements, we can have people in their car, out of their car, whatever. And we're like, actually, this might be a joke. Like we might actually do an in-person conference at a drive-in that'll allow us to have as much flexibility around lockdown, non-lockdown procedures as an event venue possibly could. And it went super well. Also seeing talks on a drive-in screen was really cool. Not gonna lie.
Awesome. I love it. And then April, I want to bring you back just for a second and just say welcome back to the show. I really appreciate you coming back here and being part of this panel. And I'm actually going to ask you this question first. And we'll get into taking questions also from our audience. If you'd like to use the chat windows that you've got in your different services. We want to hear what you might want to know, but we've got a couple questions ready to go. And so the first one I am going to ask, and I'll ask you first, April, is how do you differentiate observability from what is traditionally known as monitoring in IT systems?
So when we think of monitoring, and I spoke a bit about it as well, it's in that kind of final phase of deployment, right? We're monitoring around something. I feel like observability is the full end-to-end process. So it's not just the monitoring piece, but it's how do we track things throughout and have that visual ability throughout. So I spoke about it a little bit before when I talked about Azure boards and the planning tool. Like we have full visibility within the organization, what we're doing. We have automation built in, so we know what's happening. And that might be hooking into Microsoft Teams or whatever chat tools, Slack, et cetera, we use in our organizations. And having that ability of what's going in the whole process and not just the monitoring, that's the quote infrastructure and app movement, but also the whole process that's in the DevOps cycle. So that's everything end to end. And in my demo, for those of you that tuned in, we could track the pull request number to what we're doing. And you can take that even further by hooking in GitHub, into email notifications, into like a chat ops thing where you have it notify a Teams channel. So for me, that observability is in the full end-to-end process in DevOps, not just the monitoring wraparound.
Absolutely. And so, Alex, I know you've had probably one of the beginning introductions of SRE to the world at your time. I believe it was at Google, and really understanding how the process of observability fits in. And so I ask you, how do you kind of differentiate it from, say, the old style of, putting in Nagios or something like that to keep you abreast of what's going on?
Yeah, I mean, the first thing is that, one, I'm a nerd. And this means I really kind of love the original definitions of a lot of these things, right? The concept of observability existed way before microservices. It's part of control theory, which is, a way to think about complex systems. And, and we don't have to get super in depth there, but the point is the original definition, I think, actually still really holds. And monitoring gives you things that you know to look for, known knowns or even known unknowns. But what really makes observability different is the concept of emergent behavior. Right? Emergent behavior, or emergence, is the idea that you cannot possibly understand the performance or the traits that will be exhibited by a complex system until the many components of that system are actually interacting. And so monitoring generally means that you have a developer writing the code says, I'm going to export this metric. I'm going to send this time series out. I'm going to log this log line. I'm going to use this framework to ensure that these 500 metrics are all being emitted from my service. And that's awesome and important. I actually don't think observability replaces monitoring in any way whatsoever. You need all that data. But proper observability means having the systems in place, having the data available to you in order to explore and locate those emergent behaviors. The ones that your developers cannot think about ahead of time. The ones that your developers cannot say, oh, I'm going to add this log line. I'm going to add this metric. I'm going to export this to our system, right? These manners in which complex systems and the components of them interact with each other, you can never know what they are. And observability means being able to track what those potential issues are.
Great. And Quintessence, I'd love to get your take on this as well. I know that PagerDuty, it's a big part of that process, because you're letting people know when these events happen. And so I'm curious about how you differentiate observability from monitoring.
So it really goes back to a bit of what Alex said, where if you take a step back and say, what is observability? And he mentioned control theory briefly, and I'm also going to mention it briefly, but very specifically, we talk about the outputs of a system. So when we talk about observability, we talk about a highly complex system usually these days, right? And so you can't really know the state of the system linearly from a tiny little app. You need to actually know what it's outputting in order to know what state it's in. So that's observability. And if we look at what observability is typically supported at, I hate pillars. It's that whole allergic to buzzword thing, but we'll go with it. So, right, you have metrics, events, logs, and traces, right? And if we shift over to monitoring, what is monitoring? What do you fundamentally monitor? Normally, you're monitoring maybe metrics and also logs, right? So when you think about it like that, monitoring is kind of a subset of observability, in the sense that in order to have monitoring function, you have to have a system that's at least partially observable. But having only monitoring configured by itself does not mean that your system is observable, per the previous, which is, can you actually deduce the state your system's in from monitoring alone using only metrics and or logs? No, right? You haven't implemented enough. And so I feel like they're less like different than one is a superset of the other.
Awesome. I'm thankful. Like I think have a good kind of groundwork for what we're going to continue to talk about by understanding kind of that difference. And there's been a term used so far, complex systems, and I really think about how complex systems fail. The paper by Dr. Richard Cook, and if you haven't read it, I really recommend it. That really made me think a lot more about the implementation of SRE in general, because I think that complexity begets failure. It's just a part of how things work in this world. And so because you brought up that term first, Alex, I'm going to ask you, what points of data do you believe have the most relevance in regards to understanding a complex system?
I mean, that's a difficult question. And I think it's because complex systems are almost by definition unique. I don't think there necessarily is a list you can check off of saying, oh, I have a complex system here, therefore I need to be watching A, B, C, D, because every situation is going to be different. How these complex systems are composed, what their components look like, how those behave, how they've been introduced, what order they've been introduced in, are all going to really kind of change what is most important, perhaps, to be looking at for any system, like in and of itself. That said, I do think that you can kind of identify a subset of things that you need to be looking out for, because generally speaking, complex systems exist in order to they have a goal in mind, right? We design them in order to execute a task. We as humans design them to do something for us. And knowing what that output is supposed to be, right? This kind of goes to what Quintessence was saying, right? Like the original definitions involve what can you infer about the internals of a system by its outputs. The best starting place you can have, even though you can't have a perfect roadmap, you can't say, oh, I need this. The closest you can get, I think, is to say, okay, the system was designed to do X, and therefore the output should hopefully look like Y. And that's a great place to start.
Great. So I'll defer next to April. What do you believe are some important data points in a complex system?
I think they're called complex systems for a reason. And in my career, when I worked with engineering prior to joining advocacy, a lot of my role was breaking down complex systems. So, just like Alex said, what is it supposed to output? What is it trying to do? And how do we get there? And in a lot of the times, it's breaking that system down. And that's been a hard task. And it depends if you're looking to transform it or what you're trying to do with it. Why are you breaking it down? Why do you need to figure out what it's doing? And is it doing what it's supposed to? A lot of the complex systems that, most people out there have is because we've built something and it's grown organically over time. And we didn't think about how we're going to scale something. So I think it is such a hard thing to measure. And each complex system that I've worked with has always been different. And we've had to have different points in which to measure it from and how it works. And we have to break it down. So for us in the engineering side, when I was in the engineering side of Microsoft, like we really had to break those down and find those. And each system was different. It could be very code heavy. It could be very infrastructure heavy. Each was so different. And a lot of times they didn't have, quote, monitoring around it. We didn't have observability around it. We knew X didn't produce Y or didn't do Y as it was supposed to. And it kind of limped along. So we need to figure out why.
Gotcha. And so Quintessence, I'll ask you the same thing. What data points do you think are important to kind of track in a complex system?
So it does kind of go back to systems aren't complex, so you're not going to be able to have a checklist of data points. However, complex systems are not unique to IT. It's something that we borrowed, mathematically speaking, from gestures vaguely, right? When you're in certain levels of mathematics, you do a lot of modeling around species and populations for complex systems and whatever. And all of this is to tie into the fact that there is kind of a definition for like qualifying criteria for what a complex system is. And you have numerosity, disorder, diversity, feedback, and non-equilibrium. And when you're thinking, what data points do I need? If you understand those 4 to 5, depending on how you separate them out, points, you can start to say, what data am I outputting that tells me these different criteria so I can see how complex my system is. So like numerosity is how many things do I have? Microservices, dependencies, whatever you define thing as. And then you have diversity. How many different things do I have? Do I have a dozen microservices and 5 libraries, whatever? And as you go down the list, what is equilibrium and non-equilibrium state? And this goes into monitoring percentiles and exceeds the scope of the question a little bit. But when you start to think, okay, I understand what a complex system is, and you start funneling data back up in, now you can start asking questions to tell you what type of data you should be focusing on. So less prescriptive than please check your, inbound traffic. But it does tell you if you do need to check for that, like where it falls under when you're trying to figure out your complexity. And you also need to, you also need to check randomness, and that is how chaotic is your system. That chaos experience is great for that, but.
You just led into my next question.
You're welcome.
So you mentioned chaos, and chaos engineering has become a really big another buzzword, if you will, and it's actually become a great way of finding problems and using observability before the problems actually impact production. And so I'll ask you, Quintessence, how do you feel that testing in production fits in to this whole kind of observability as opposed to just standard monitoring?
I'll say what everyone else probably also says. You're always testing in production, whether you mean to be or not. I feel like I have to say it. Someone else will. So I beat you both to it. Sorry. Intentional testing in production, mostly you need to make sure you're doing a lot of pre-work, because even when you talk about like chaos experiments or things that can be done to kind of give you more reactive outputs to check for than you thought to, the whole known, unknown problem, where you start to know what to track, but then you need something to tell you what else you're not tracking. You don't want to just start running chaos experiments in production without running them in dev or staging first. So a lot of the testing in production, when you're doing it intentionally, kind of goes through this planned phasing of, even though they're smaller but hopefully mirrored versions of production, you roughly know the radius of impact of everything. And that is to say, you don't want to be in a situation where you think you're testing something that's confined to US East. We're just going to use AWS. Why not? US East. And then all of a sudden it's creeping up in APJ over here. You're just like, I didn't think these were talking to each other. And now I can't shut it down. I can't shut down the experiment because
Awesome.
I didn't plan it out. Yeah.
So, April, how do you think testing in production fits into the observability story?
Well, I think Quintessence summed it up well. You're always testing production. And I think this is where it's important to have like-for-like systems. We've seen a lot of customers that are like, oh yeah, we found this thing in production, but dev test or staging looked completely different than the production environment. And I'm like, well, you're not testing in production. You're actually testing on something live that your end users are seeing. So you really have to think about, how are you testing it? You want to test any small, you want to either use feature flags or use different environments that are like for like, and how you can replicate that. And I think we see a lot of people that don't have that set up and will test and are actually then just scared to do things in production. And that is difficult because they're not getting that feedback mechanism. But those that are willing to test in quote production or something that's like for like, they're getting that feedback earlier and they're having that identical system. And I think that's really key to getting that feedback and addressing it, because I think also when we talk about these big complex systems, if we're then doing these things, 3 months past or 6 months past, we don't know how to fix them. So this has to be done incrementally if we are doing that in a direct production environment.
Great. And Alex, I'll give you a chance to kind of give your thoughts on testing in production as well.
Yeah, so I think it fits into the observability story because they both kind of have the same aim, right? They almost have the same goal, right? An observable system, you build more observability into your systems. Again, to go back to identifying emergent behaviors, things that you hadn't thought of ahead of time, things that you hadn't already planned for. And that's what testing in production, that's what chaos engineering, that's what experimentation gets you as well. It exposes new ways that your components may interact and new failure modes for those components and your complex system overall. And, if you don't have observability, you may not even be able to notice those things. Something may break and you have no clue why. So you're running experiment X and thing Y happens. If you don't have proper observability, you learn nothing from it, right? You do know that X causes Y, but you don't know why X causes Y.
Absolutely. Very, very cool. And so, we've covered a couple things, and I will ask you, Alex, to kind of bounce off that. And someone wanted to know, does chaos engineering, is it even considered a part of observability? Are they related? And I personally think they are. I think that, reducing failure or improving reliability of complex systems is kind of one in hand with the other.
Yeah, I mean, I think they relate in the way I just kind of mentioned, right? Like you need proper observability, otherwise your chaos engineering work is not going to be very useful, or at least not as useful as it possibly could be. I don't necessarily consider chaos engineering or continuous verification is a recent term to encompass as part of this that I really like. I don't know if it's necessarily part of observability, but you can't do one well without the other.
Sure, absolutely. Well, I've got about, I guess, maybe one or two questions left, and I'm going to ask a lightning round here around tooling. So, Quintessence, what type of tools can help best identify problems before they impact end users?
So it's less about very specific tools like use this vendor, et cetera, and more about, again, understanding what you're trying to gather. So when we go back to like metrics, events, logging, and tracing, choose a tool that does one or more of these things well. And by well, understand what you're outputting and know how unique you are and how normal you are to everybody else, so that you can say, okay, am I an edge case? And does this vendor like meet that need? Or do I very specifically need to use this specific person because we're doing something wonky for whatever reason? Wonky, highly technical term, right? So when you're looking at tools, make sure that you're supporting all of those. And the reason it's good to balance tool explosion with what you're putting into the tool is because you don't want to do the tab thing where you're like data crawling through your system and you have like 5 tabs open and you're like, this correlates to this and this correlates to this. So having it reasonably consolidated and accessible to the whole team. And by that, I mean, don't just make it so infra can see infra things and front end can see front end things, because they'll need to talk to each other, right? So everybody kind of needs access to the same level of data for the most part, unless there's like a secure reason to not do that. Yeah, that's really why I would go with it.
So Alex, I'll ask you, I know that, as a person involved in SRE, you implementing this type of tooling to actually keep an eye on the observability and health of your applications is big. What do you think is an important tool that people can implement?
Math. Just simply understanding that there are models that have been created decades, sometimes centuries ago, to better understand what data you're actually collecting. It's very easy to extract a bunch of telemetry from your systems. Well, not always easy. Sometimes that is difficult, but but then you have all these numbers and you have all this data and you have all this telemetry, and then what do you do with it? And just having a basic understanding of basic statistics, regressions, correlation analysis, even something a little higher level like using service level objectives, right? Something that kind of provides you a summary overview of things as opposed to just having, tens of thousands of time series, like that you don't know what to do with. I've learned more math post college than I ever did in college, like at this point. And, I'm certainly not an expert because I use programming languages to actually do the math for me. But I think it's very important to at least understand what kind of models exist, what kind of formulae you have available to you to better understand what's actually going on.
Great. April, what tools do you think can best help people out?
And again, I think the specific tooling there's so many out there, and you have to find the tool that's best fit for what you're trying to do. And I think my biggest piece of advice to organizations and people out there, use the same tooling across the different groups in your org. I've worked with different organizations that use like 16 different tools. I'm like, which one should we use? Or how do you do it in this tool? And I'm like, why are you using 16 different tools? I'm like, oh, we let each group pick their tooling. So there's no continuity. So the data they're collecting is just data, and it's not going anywhere. And I think it's really important to look at the data, know how to, what you're looking at, so you have a baseline. So whatever it is you're trying to improve upon, you need a baseline bit of data, you know how to improve it and where it's going. That gives you a starting point. But I think getting in similar working tools across your different teams is really critical, and then doing something with that data. And there are so many tools out there. And again, Quintessence said it, you have to kind of make a list of what does your organization need? What do they need to get out of it? What kind of things are they looking at? And you have to find the tool that's best fit for the organization. But you have to use it and use it properly.
Great. So we've only got about, 4 minutes left or so. And so I wanted to ask each of you in just succinctly as what you would give as far as advice to somebody who's implementing observability. And April, I'll let you kind of kick that one off.
No pressure. My advice is find the right tool that's right for you and your teams. Implement it early, start gathering metrics, use that data. And again, we say it in DevOps, fail fast, start using it, find what works, find what doesn't, and move forward.
Great. Quintessence, would you like to kind of give your take on this?
I'm going to echo what Alex actually said about using math. The idea, a really easy example, low-hanging fruit is percentiles, right? Know what the numbers mean. So if you say, oh, I'm using averages, that means you're in your good state 50% of the time. If your SLO is 99%, it doesn't help you. So knowing the math for why you're making the decisions to watch what you're watching and gather what you're gathering will really help you, both in terms of what things you're going to be outputting from your system and thus drive what decisions you make about what it's getting put into.
Absolutely. Alex, so last, I'll ask you to kind of give us that same quick answer.
Yeah, I mean, I have a lot of opinions here because I've been on pretty observability focused teams for the last 6 or 7 years of my career, 8 maybe even. So I want to answer from a business perspective. These systems are expensive and are likely going to be your busiest if you're not using a vendor, right? If you're building something in house, because everything else you run has to talk to those systems and has to send them data. So I don't care how huge and important your primary web app is. The observability tools behind it, your logging systems, your metric systems, your tracing systems, like your production event change logging systems, whatever they may be, they're going to be busier. They're going to be more difficult to maintain than your primary, profit driving, web application. So
Gotcha.
give them the right resources in both money and humans.
Well, thank you, Mr. SLO. I do really appreciate that answer. I think we've had a great time having this conversation. I'm going to start getting ready to say goodbye to 2 of our speakers. One of them is going to stick around. But Alex, where can people get in touch with you on the internet?
Find me on Twitter. I use it too much probably, but you can find me at AEDoggo SRE. And go check out what we're doing at Noble 9 at nobl9.com.
Very, very cool. And April, I know you've got the DevOps Lab and lots of other things going on. I know that that's coming back in a couple of weeks. Any other way people can reach you on the internet?
Yeah, everyone can follow the DevOps Lab on Twitter. We have a YouTube channel. Feel free to reach out to me via Twitter or LinkedIn. If you send me an email, it will go down a black hole.
Well, I guess you and Kat have a lot of things in common as far as your emails are concerned. And so I will say goodbye to April, goodbye to Alex. Thank you both so much for joining myself and Quintessence here. I think that I really enjoyed this conversation. And the conversation will continue. We are getting through this. We are so deep into this whole create DevOps thing, Quintessence, and we've got a great keynote that's going to close up the talks portion of today that you're going to be doing with my buddy Steven, talking about beyond the scope of development and operations. And I know, DevOps itself, it's over a decade old.
Yeah.
And there have been so many changes to not just the process, but the tooling and the culture has moved ahead as well. Hey, Steven.
Hey, that was a wonderful panel, and I'm looking forward to seeing hearing a little bit more from because I'm old. You can see that, and so I've been around for a whole lot of this DevOps, the evolution of DevOps, and kind of where it's gone over the past 10 years and how it matched a lot of what my career looked like. And so I love this space. I love hearing more about it. And so I can't wait to hear what you have to say.
Yeah. So let me go ahead and share my screen here. Let's see what it's going to let me do. There it is.
All right.
Hopefully. Yeah. All right.
Go.
Okay. And so I'm going to be talking today at DevStar*Ops, and I'm talking a little bit about going beyond the scope of development and operations. And in order to get started, kind of keeping in alignment with what Kat did, I want to talk about what DevOps is very succinctly and not just, presume age or not. So DevOps started to coalesce around 2008. trying to solve the problem of siloed workflows. The most famous and like storyboarded form of this is the Phoenix project. If you're newer to DevOps and you're new enough that you don't know what the before world was like, I recommend taking a look at the book, because that's the thing that everyone really references when they start to talk about how frictionful things can get. But what was ultimately being solved for was communication issues. You had a dev team building, the mobile apps and the backends and the front end, and it was vaulting over to operations that had to push things live and do other tasks around the supporting infra. And this vaulting behavior caused a lot of friction. People didn't communicate well, and because their backgrounds were disparate, and by that I mean dev didn't really know why or how operations did what they did and vice versa, they couldn't really contextualize what they sent over or think ahead and say, what would this team need from me? And again, vice versa, ops couldn't offer that back. Now, as much as there is a certain beauty to working in a temporary silo, you can see how when you scale it out, it's a problem. Temporary silo, you get focus time. Permanent silo, you get groups that can't talk to each other, and that's not great. It causes all that lack of understanding. What I would like to do is roll back, and it looks like, oh no, it's still there. Okay. Roll back for a minute and talk about what DevOps is kind of more abstractly. So before we talk about DevOps kind of being that union point between development and operations, and if you ever look up a DevOps diagram, you'll see this very familiar-ish infinity diagram with the dev side and the ops side, and then the union in the middle is where everyone's focusing on those handoffs and that mutual understanding. When we talk about that, though, we're really talking about project management, pipelining, automation, observability, continuous feedback, and collaboration. These are things that DevOps was designed to solve for. But if we start to go back to what I'm really going to focus on for the next little bit here, is about neither dev nor ops, right? Kat talked about it a little bit earlier with DevSecOps, where people like to talk about integrating security into the workflow, and I have things to say about that. But I'm also going to talk about data science for a hot second and explain why I chose these two things. So first of all, why we're not talking about neither dev nor operations, and starting with security. Security has always had an important role in the release of software. It's not like security suddenly appeared when DevSecOps started to gain traction. What did start to gain traction was a formalized way to integrate them in the process. And again, when you're looking at a DevSecOps diagram, which this is not, but I'll get to this in a second, when you're looking at DevOps, remember, it's an infinity diagram with a dev side and an ops side. When you look at a DevSecOps diagram, a very simple one, it just wraps security around the whole infinity shape. And that's all it does. When we tie that in with this idea of a secure development lifecycle, we can see more to what Kat was talking about with regards to integration. You're integrating security. You're not just appending, in an infinity and then another plus shape over here. You're really wrapping it around. You're putting it over the whole process. I'm using this as a prescriptive example to try and show kind of what that means instead of just hand waving that it wraps the whole cycle. And when you look at the secure software development lifecycle, you can see the familiar pieces running along the top, pipelining and automation and runtime and everything. And underneath that, you can see very prescriptive examples of what security can do at those phases, which is why you're not just shifting left in the sense that you do something at the beginning and then stop. You're doing something at the beginning and then continuing to do different somethings across the whole life cycle. And I want to start with this because, again, going back to DevOps, when we remember what this looks like, we can see that security is doing all of these things. Security has its own project management. It may or may not be agile as we associate it with either dev or operations, but they have to manage projects in order to get this accomplished. They're doing pipelines. Some of these tests are put into pipelines. Some of them are not. Some of them are automated and some of them are not. You have to have observability and monitoring to make sure that you don't have a secure incident, and so on and so forth. And you can see that this runs very parallel. And some of this gets a little intuitive. So the reason I'm talking about beyond dev and ops for dev * ops is that there are more parallels between the different disciplines than just dev and ops than the name maybe implies. And then pivoting for a minute, let's talk about data science. And the reason I'm talking about data science is to choose a technical discipline that we do in fact interact with, but that doesn't have I'm going to say buzzword lovingly attached to it. It's not DevSecOps, right? Or when you look at network engineering, I think there's net DevOps or DevNetOps or something like that. There are other terms that DevOps that gets concatenated with DevOps for other teams, but data science isn't really one. However, when you start to research data science as an outsider, you'll realize a few things. Just like people in DevOps, they spend a lot of time getting requirements and planning their work, which starts to feel very familiar. And in their case, they also spend a lot of time figuring out what data to gather to meet those requirements and how to clean it. And to really kind of dive a little bit into what I mean by that, since I'm intentionally choosing a less familiar group, let's say they're working on a salary survey, something that's, I think, well understood outside of, just we all make salaries, right? You need to know what questions to ask, and you need to know how clearly to ask them, or else you're going to run into situations like people putting things in the wrong currency, or people assuming that you're doing things in a salary versus an hourly, or an hourly versus a salary, and then you don't know what data you're converting. So there's a lot of cleaning that's involved, because more likely than not, you're still going to get some errors in the data for these reasons and possibly others. People might enter 80 instead of 80,000 in some currency. They might enter the wrong currency, right? If they don't know you're trying to level set across something. If you're not limiting a survey to a specific geography, it could look like the max and min values for a certain role are very broad, but that might actually not be true in practicality, because some countries have nationalized healthcare, some don't, some are compensating for that, some aren't. And we keep going down this list. And this is just for something as relatively simple as a salary survey. But when you think about it, development and operations and other groups are working with data science more and more, because every time there's a product released with machine learning or AI ops, you're involving a data science team. And when you're working with them, now they're taking some of the experience that dev and ops have with regards to how to train the same data sets, except instead of salaries, now we're talking about maybe something about observability. Maybe we're talking about metrics and metrics behavior. And going back to questions that were asked in the panel, we have people who are saying, how do you know that something's going to be production impacting? Well, you start to learn, and learn for a machine is a very different thing than for a human, but you start to identify these precursor behaviors in your environment so that you get notified on them before you get notified about outage, hopefully, right? And this is all stuff that falls under the purview of data science. Now, you might be thinking to yourself, that's great. And you might be wondering why I'm talking about it quite this way. And the reason I'm talking about this is because both of these groups have been typically viewed as kind of outside of the dev and ops workflows, but we work with them, right? Yep. Security maybe more directly. And then we go right into the data science, where there's, on the one side in security, there's a normalization for security now. But in data science, there's less so, but it's becoming more and more. The reason we want to be able to abstract away what DevOps is and how we implement it is so that we can avoid the friction that we've had between dev and ops, and then between DevOps and security when we start to go into other groups like data science. And we can say, this is how we're similar and how we're different. And if we start making that skill very flexible, we should be able to integrate with anyone, even librarians, which is why I just love this image. I do. But the idea is to know how your workflows can integrate with the others. And with that, I am throwing up, if you want to see this slide deck, it is on the link that's on the page. And I am available for questions here. I'm also available on Twitter. All of that info is on the slide there.
Oh, very, very cool, Quintessence. I love how you started with the dev star ops. Back when I worked at Stack Overflow with Tom Limoncelli, he would always say star ops, right? Because it was always like trying to figure out how development and operations have to work together, but how do we also work with the other parts of our organization? And so I love hearing your thoughts on that as well. We did have a couple questions come in, and
awesome.
Let's see. So we have that. Where do you see the future of DevOps going? Everything is code.
I feel like these are slightly different things. So we have DevOps, which is the cultural practice of integrating workflows, and then the code movement, which is solving a very separate set of problems. So when you're talking about things as code, most normally things as code is really mostly translating to infrastructure as code or infrastructure as software. I I would say that these are separate things that are both happening. We use DevOps because it's what works for us, very loosely defined as development operations and other IT adjacent disciplines. And then insofar as code, as we hit scale, we had a very specific set of problems that we did not have before. So I know when I was doing, for example, DBA work, we didn't have much with regards to things as code. And there was a lot of WYSIWYG. And you would set things for the networking or whatever, and then you would have to document what you set because there wasn't a way at the time to interact with it. And then we had code, and now you can do things like Terraform, and you can write up what the settings are. And now you have something that's documented and version controlled, and at least you have that. But now as complexity continues to move forward, now you need conditionals and all sorts of other things so that you can have a common set of requirements that are going through, am I in production or staging, or where am I, and make different decisions like that. So everything as code is really more of a complexity problem, and DevOps or DevOps is really more of a how do we as IT professionals with distinct disciplines work with each other.
Okay, wonderful. So we have just a couple of minutes left, and we've got one other good question, I think, here. Do we think that SRE will make DevOps irrelevant?
Again, slightly different things. Slightly different things. So DevOps is about getting two different groups to work together. SRE is a specific set of codified practices. What? Sorry, you froze for a second.
Oh, yeah. I love that I get to lob these questions at somebody else instead of them coming to me for a change. So.
Oh, I get you. Yeah. So site reliability engineering is really a codified set of practices for how you run things, highly technical term, in production. That's really the goal. How to run something, how to keep it running. DevOps is still focused on the cultural aspects. So SRE might be fundamentally people with, for example, an infrastructure background, but those infrastructure people working with the mobile developers would be DevOps, right? And then them actually running the mobile site or whatever would be SRE, right?
Yep.
So they're not going to make each other irrelevant. They're just going to keep running in parallel.
Yeah, I think what some people find conflicting, maybe because these two things have evolved around the same period in time, and there's overlap in the perceived coverage of them. But yeah, DevOps definitely leans more heavily into the culture of how do teams work together, where SRE it tends to be a much more focused and prescriptive way of approaching operations, as you described. So with that, thank you so much for all you've shared with us today, both in the panel and the closing keynote. Let's bring Jay on back here, and we have one more thing for everybody that's coming up yet. We have our workshop. So you've stuck around.
Yep, you stuck around. You did the hard work. Well, like I said,
we now
Stephen's saying. Oh, go ahead, Stephen. Stephen, you're breaking up a little, so I'm just gonna. So now we've got coming up next a workshop, and let's bring that up there. Thank you very much. It's a hands-on workshop that we're going to be doing. That's about deploying Bicep templates with GitHub Actions. April touched on what Bicep is briefly, and Marcus is actually going to give us some more detail on how there's been an evolution around ARM templates and how they've changed Azure Resource Manager templates. Hey, Marcus, how are you today?
Hey, Jay. Doing great.
Great. Do you want to give us a little intro, like executive summary of who you are, what you do?
Yeah, sure. So, hi, everybody. My name is Marcus Felling. I'm a PM from Microsoft's developer division. I've been helping with Bicep recently, which I'm excited to tell you all about.
Great. So, I think the next big thing that we're going to do is start working on our workshop, and to get started with our workshop, I know we've got some slides Stephen has got up here. And so this workshop today is going to be focused on how we can get our apps deployed and do that securely, and do that with an automated process utilizing GitHub Actions and Bicep templates. So we're going to remind you all that there's tons to do here, and if you don't necessarily have the time to do it all right now, this is recorded and it's well documented. We'll show you the repo in just a second. So why don't we jump into it? What do you say, Stephen?
Sounds good. And just to remind everybody that if you're participating and sharing information out on Twitter or your other social channels of choice, don't forget to tag Microsoft Create, Learn TV, and tag your stuff with a hashtag. All right. So we still are under the same code of conduct as we were for the previous event. But Jay, why don't you run us down our agenda here?
Sure. So we've got a couple things that we're going to be doing today. First, we're going to be reviewing the components of our total workshop. We're going to be talking about how to configure our dependencies. We're going to secure it all with Key Vault, and then we're eventually going to deploy our app to Azure Kubernetes Service. And so there are a few prerequisites, Steve, that we need everybody to make sure that they've done. If you want to go ahead and move us forward. The prerequisites are an SSH public key. We'll show you pretty quickly how to make one. We're going to ask you to use the template. Use is an interesting term that they use, but you're going to use the template. Make sure that you've signed up for Azure and get your $200 of free credit. And then eventually you're going to clone the application locally. I'm going to be using Visual Studio Code, or you could use the Azure Cloud Shell to do a lot of the things that we're doing today. And so if you move forward, we'll just remind you, you can sign up for Azure. You can go to aka.ms/CDA free Azure. That way you sign up. Next, we want to remind you that there is a Bicep, and I should call it the AKS Bicep workshop. That you can go to the repository right now. And what you'll want to do is, you see that green button, you're going to want to click that green button. And what you'll be able to do is use the template. When you use the template, it's going to create a copy for yourself. It's not necessarily like forking it. It's just going to create a template. And if you move forward, you'll see it'll create a new repository for AKS Bicep Workshop, or whatever you decide to name your repo, and we're going to be creating a demo application that is pretty regularly available within Azure. It's just a simple voting application. It's using Redis on the back end, and I believe it uses a .NET API that is front-ended by some JavaScript. And so rather than waste time, I think it's time we get into the big idea. Marcus has got some information for us. Why don't you kick us off, Marcus, and answer the question of what is Bicep?
Yeah, let's do it. If I could get those slides back up on the screen. This is not the right screen. If we could share Stephen's
screen, slides. My slides.
Oh.
All right.
All right, there we go. All right, so let's start out with describing what exactly Azure Bicep is. So it's a domain-specific language for deploying Azure resources declaratively. So you can also think of it as the next generation of ARM templates, which you've worked with in the past. Come with the burden of working with JSON, right? So Bicep has a simpler syntax compared to the ARM template JSON. With none of the JSON noise. So it's really aimed at simplifying that authoring experience. A good analogy for understanding the relationship between Bicep and ARM would be similar to the relationship between TypeScript and JavaScript, where TypeScript is Bicep and JavaScript is ARM. So Bicep transpiles down to standard ARM template JSON files, which means the ARM JSON is effectively being treated as an intermediate language. All this work is being done in an open source fashion out on GitHub. It's been open source pretty much since day one. We wanted to get the community involved as soon as possible to really help shape the future of the product. So Bicep has a really readable and writable syntax. Similar to ARM templates and Terraform, Bicep is a declarative language where you say what you want, and then Azure kind of just makes it so. Opposed to imperative approaches, such as the Azure CLI or PowerShell, that would require you to tell Azure how to do things kind of procedurally. So with Bicep, you don't need to worry about the complexities of the how. With modules, you can break your Bicep code into manageable chunks. This is a way better experience compared to linked templates in ARM templates. If you've used that in the past. Modules are super easy to consume. Bicep has a first-class authoring experience, which I'll demo here shortly. It has features like rich type safety, validation, IntelliSense, and a number of other features that I'll highlight. Bicep also offers a decompile command, so you can take any ARM template and it'll convert it into Bicep code for you. That way, if you've invested in ARM templates over the years, you're not starting from scratch if you want to start using Bicep today. So these are some of the reasons to choose Bicep over other declarative tools. I have a blog post that goes into more detail on each of these with the link at the bottom of the slide there. With tools like Terraform, there's potential for a delay between new Azure resources being released and them being available to use and consume. With Bicep, new resources are supported immediately, and there's no need to wait for them to be added to the provider. With Bicep, the state is managed by Azure, so there's no need to manage state files like in Terraform. Azure really is the state. You can query it at any time. When deploying a Bicep template, there is pre-flight validation on the entire template, so you can fail fast. Resource Manager checks the template before starting the deployment to make sure the deployment will succeed. And because of that, your deployment is less likely to stop in a half-finished state. Bunch of really great tooling. The VS Code extension, like I mentioned, there's integration with the Azure CLI and Azure PowerShell. We have the Bicep Playground you can use to experiment with Bicep without needing to install anything. The Azure CLI integration is really slick. You don't even need to download and install Bicep. It'll download and install it on the fly when you issue a Bicep command. And then the last note on this slide, it's fully supported by Microsoft support plans.
Wonderful. So I know you have a little something to show us as far as how everything is demoed.
Yep, if I could get my screen sharing up. There we go. All right, so I'll just highlight some of the features the VS Code extension has to offer that really makes authoring Bicep code a first-class experience. So we can start out by searching the marketplace for the Bicep extension. Here I already have it installed. If I didn't have it installed and I start authoring a .bicep extension file, VS Code will suggest that I install it. So now that I have this installed, I can start in my 0.bicep file. And the first feature I'll highlight is snippets. So say I want an AKS cluster, I can start typing AKS, and you'll see there's a snippet available. So I'll click enter, and then I can tab through this and set these properties. And you'll see on these properties, I'm getting some pretty cool IntelliSense here. So I don't need to guess and go look at the docs to see what I would want set. I can also hover over all the properties and get a description of what they mean. So pretty cool. This gets me up and running pretty quickly, so I don't need to start from scratch. There's a ton of resources that have snippets. There's a long list here. You can even go and contribute your own snippet by going to our GitHub repo. Right at the root of the repo, there's a contribution guide with instructions on how to do so. So pretty cool stuff here. Similarly, we have scaffolding. So if I define a resource type here, like an alert rule, I can use a feature called required properties. And this will look at the resource type's Swagger API spec. And it will tell me all of the properties that are required so I can get up and running very quickly. All right, here I have a Bicep template. As you can see, it's getting pretty long. This is the first time I've looked at this template. I'm going to right-click on this and use the visualizer. That way I can get a good visual representation of all the resources I'm creating in this template, as well as the dependencies between them. It's pretty cool stuff. And then next up, I have the linter. So this is going to inspect my code as I'm typing and catch a customizable set of authoring best practices for me. So as you can see, I have a bunch of squigglies that indicate I have some linter rule violations. I have the option to set certain rules as warnings, errors, or disable them altogether. I can configure all of this. So if we start at the top here, I hover, I get a description on this linter rule violation. It's telling me I shouldn't hard code a password. That's probably a good idea. I'm going to check this into source control. I wouldn't want to do that. I'm going to use the quick fix, which most linter rules have here, and that'll clean it up for me. Next up, I have a parameter that's declared, but it's not actually used anywhere. So again, I'm going to clean that up as well. Kind of work my way down here. I have 2 more warnings left. If I hover over this, it's telling me I don't really need to use string interpolation. It's not necessary. I can just reference this parameter name directly. I might not know what that means. So again, I'll use the quick fix to help me out there. And then the last one down here, I'm using the concat function for my automation job schedule name. Again, string interpolation is preferred for this one. It's a little bit cleaner syntax. Use the quick fix and show you what that looks like. All right, cool. So I have this template all fixed up. Looks like my warnings are all gone. So the last step I'm going to take is right-click build. So this will run the Bicep build command for me. So I don't need to craft a command at the command line, and it will ensure that the transpilation process is successful. All right, and that's all I have for my demo. So I'll hand it back to you, Jay.
That was really cool there, Marcus. I hadn't actually seen the visualizer before, so I like that. Do we lose Jay? Possibly. We can go back to the slides, and so until Jay gets back, I can continue on. We can talk a little bit about GitHub Actions. Now, GitHub Actions are going to be one of, we've talked a little bit about them throughout the day here, but we're going to really take advantage of these things as part of this workshop. Now, GitHub Actions, it's not just CI/CD. It's world-class CI/CD, but it's not just CI/CD. It's automation for any workflow that we want to do around things that happen in our project on GitHub, right? So, we can comment on an issue. We could use it when somebody forks our repo, or even just on the regular schedule. There's dozens of different events that we can use to trigger workflows. Now, in addition to all of that, it is really good for CI/CD, so we can deploy things almost anywhere. Now, Jay, did you want to pick up, or you want me to continue rolling on here with?
Sure. We actually can go ahead and start really getting into the demo. So Marcus is going to stick around and help us if we need around Bicep. But why don't we bring up my screen and let's just jump into it, because we've got only so much time left, and I want to go over what exactly we're doing here. And so we're going to be using Azure Kubernetes Service as well, and AKS is a hosted Kubernetes service. Key Vault, it's another great service. You can get full descriptions in the repo. You can see Key Vault protects cryptographic keys, certs, and secrets. And so what we're going to do is create a few of these, put them all together, and then utilize a Bicep template to actually kick off the creation of our infrastructure. And then after and you can see here on the left side, just make it a little bigger for you. We've got all these parameters that are actually going to be called from a parameters file that we would normally use with ARM. But as you can see, the syntax within this Bicep template, if you've used a ARM template before, you can see it's a little bit simplified. So we have things like we're creating our OS and specifying what disk size there is. We're giving a username. We're also giving an an SSH RSA public key. And if you haven't created a public key yet, it really is as simple as running this command, ssh keygen -m pem t rsa -b 4096, and it'll actually encrypt an SSH key in 4096 bits, and then eventually allow you to save it. I've already got an RSA SSH key created. I don't need to do that. So as I mentioned before, what we've done is we've used the template, this AKS Bicep template, and I've gone ahead and I've created my own, and that is just called AKS Bicep Create. And that's going to allow me to utilize GitHub Actions so that we can actually run our deployment. So I'm just going to scroll down and show you. We've gone ahead, we've taken care of our SSH public key, and we've used the template. We've signed up for Azure. And then what I've done is I've cloned the repo here in VS Code. So you can see everything that was in our repository on GitHub is here. That includes our deployment workflow for GitHub Actions. So you can see that on the right side, our deployment file is just some YAML that specifies what we're going to do and how we're going to do it. And we've got some environment variables here that we need to go ahead and set. And to do that, what we're going to do is, one, we're going to need a resource group. A resource group is where we put our stuff for Azure. And so I'm going to just set some variables to do so. I'm going to set my location as East US. And then I'm going to give a name to the resource group that I'm going to create. And in this case, it's going to be AKS Bicep Create. I'd ask you to please create yours using a unique name because you're going to actually use this as the naming convention for your actual Kubernetes cluster that we're going to create. So I've gone ahead over there. I've set that that environment variable. And what I love about VS Code, Stephen, right here, is this integrated terminal. It really makes it easy to work with. So now we're just going to create the resource group in the shell. And what I really recommend you do, just create yourself a Scratch file. Don't commit it to your repo. Just open up a Scratch file because you're going to need it along the way. And so what I'm going to do here is create the group that we're going to be working with to store all of our resources in within Azure. So it's AZ group create and using the Azure CLI. You could also, if you'd like to, do it within the portal. And it's just a matter of like create new resource group, next, last. And eventually you've got a resource group that's been created. You can see up here in this little tab I've already created my resource group. And there we go. And one of the things you'll see here is the subscription information, the resource group here. And this is all kind of necessary because we need to create what's called a service principal. And Stephen, you want to just give them a succinct explanation of what a service principal is?
Yeah, a service principal is an identity in our Azure Active Directory that we can assign rights to. It's not a person. The credential can be managed by the Azure runtime, or we can kind of rotate that on our own schedule. But it's a non-person identity that we can use to connect to or let services connect to each other.
Yep. So it's an authentication piece.
Yep. That's it.
Yeah. So what we're going to be doing here is actually creating this service principal, which is just going to be some YAML that's going to be, or I should say some JSON that's output. So I've gone ahead and I just copied this particular command right here. I just replaced my app and my subscription ID and my resource group with what we kind of just came up with to create our resource group. And what's great is when you run these commands, you get the output right here, and you can just kind of copy and paste that right into here. And so I'm going to create this service principal, and what that's going to do, and the reason I'm say it's important to have some scratch pads set up, is what we're going to get is this output of JSON that's essentially our credentials that's going to help us connect. So don't worry, by the time I'm finished, you won't be able to use any of this. So I'm not necessarily going to have to worry about security that much, but as we kept saying, worry about security the whole way. And so I know that we mentioned earlier that we can, in one of the sessions before, the GitHub Actions allows you to actually create some environment variables within to have some secrets. And that's going to be able to call these environment variables along the way. So we have here in our workflow, you can see secrets.azure.rg. We actually need to create that in order for us to be able to use that. So I'm going to open up a new browser, and then what we're going to do, sorry about that. I need to just bring that over here. So what I need to do is follow this procedure of creating these 3 environment variables. So we have 3 that are needed: Azure Credentials, Azure RG, and Azure Subscription. And those are pretty simple to set up, and I'm going to show you how to do now. So what we'll do is click the triple dot. We'll go to Settings for our repository. We'll go here to Secrets. We've got all these different types of settings for our repository, but we're going to go to this one, Secrets. And within Secrets, excuse me, you see now we can set up action secrets. And as it says, secrets are an environment variable that are encrypted. So we can put this encrypted information that we need to have as our environment variables right in here. So what we're going to do is click New Repository Secret. We'll create one first for our Azure credentials. And those are just the service principal in total that we created before. So we'll go back to our Scratch file. We'll just copy our service principal, and then we'll just paste it in here and click Add Secret. All right. Then we need to create one for our Azure resource group, because we're just going to be using our resource group as the naming convention for our cluster and some other portions of the deployment. So this is just to kind of simplify for today, because we're doing a quick demo. And so we're going to just be using AKS Bicep create as our resource group environment variable. And then finally, our Azure subscription ID. And what you can do, if you didn't already see, it came in our terminal when we created our service principal and our resource group. So we just click over there, pop this last variable in, and what we'll see is we can go and grab our subscription ID. It's always going to be in one of these pieces of JSON that you get from when you create something. So when I created my group, I got my subscription ID there. You can also get your subscription ID right here in the portal. I've got mine hidden, but what we can do is just copy this.
And if you don't have something handy in your shell terminal, you can do an AZ account show, and that will get you the basic information about what you're logged in with and to what subscription you're connected.
So we've gone ahead and we've added our secrets. And the next part, Stephen, I know you're going to show us a little bit about is creating a key vault so that we can store some important portions of our deployment method.
Yeah, so
why don't we switch over to Stephen's screen for a second, please?
Yeah, so if we start in the Azure portal, just got a quick little walkthrough here. Will only take us a moment. So we can create a Key Vault resource. I'm inside a resource group. I can click create. I like to search for using the search here to find what I'm looking for, because there's so many different types of things we can create. Find a Key Vault, click create. Now we could also do this through a CLI. We could do this through Bicep. There's really not a whole lot other than giving it a name that we absolutely have to provide to get something up and running. Now, Key Vaults names need to be unique, and we'll hit review and create. It's going to validate, make sure everything can be applied correctly. Hit create, and in very short order, we'll have a Key Vault that's ready to go. Once we have that Key Vault ready to go, we are set to start adding in the secrets that we want to protect. We can start providing access control as to who and what can retrieve those secrets, and as to how we can take advantage of those secrets, if we can use them for deployments and things like that. I think Jay is going to walk us through that part as we set some of the secrets for this demo up in a Key Vault that Jay's got running.
Yep. And so let's bring back my screen. And what we'll see is I've got my Key Vault created. It's right in my resource group. You can go and see at the bottom, just click AKS Bicep Creates, just the name of my Key Vault for today. And we've got this section here in settings that says secrets. So we're going to go into secrets, and we need to create some parameterized secrets so that we can actually access them securely throughout the deployment process. And so we've got a parameters file right here. And let me just make sure Wrap is, or I'll make this a little bigger so you can see. These parameter files all have a reference to the Key Vault. And what we need to do is specify the subscription ID. We have already got that. We need to specify the resource group and then the name of the Key Vault. So what I've done is I've just copied that line, and I'm going to just paste it into those sections. And then we're going to create these parameters that we're going to actually use for, or I should say, the parameter names. We're going to create them as secrets so that we can access them along the way. So I'm just going to paste these into the 3 sections that you can see are in the parameters. We've got 3 parameters here that we're going to be setting up as secrets. So the first one is this SSH RSA public key. That's going to make it so the Kubernetes clusters that we create, if we want to SSH into them, into the individual nodes and check what's going on, if there's something we can. So I'm going to click generate import, and the actual name is going to be what the parameter is. And that's SSH RSA public key. So I'll just copy that. I'll paste it in here. And then in here, we need to give the value. And so we mentioned that we had our public key that we created. And the easiest way to kind of grab that, if you're using, say, a Unix-based system, and WSL Windows is on Windows, or you can use this in Mac, you can just type cat SSH, and then my key name is idrsa.pub. And so there's this neat little tool that you can use within a Mac. It's called pbcopy, and that's going to actually copy my entire SSH key into my buffer, and I can just paste it here into value. And if you would like to, you can set an activation date, an expiration date. So if you have credentials that are only supposed to last a certain amount of time for compliance reasons, you can do that here. So we'll click create. The next one we need to create is the service principal client ID. And so we'll go ahead and we'll click generate import. We'll go to name, We'll put that in here, service principal client ID, and then we'll get the value from the service principal that we created earlier. And that, I believe, is app ID, right, Stephen?
Yes.
So what we're going to do is just pop in our application ID that came along the way when we created our service principal. Same process, click create. Great. And then let's create our last parameter that we need, and it's the service principal client secret. And so that's going to be just the same process of clicking generate import service principal client secret, go back to our secrets file, or I should say our Scratch file, grab the password right here, pop it into value, create. And so now we've got these 3 secrets that have been created successfully that are in Azure and can be accessed along the way in our parameters file. So I'm going to go ahead and save that parameters file. And now it's going to be part of my source control. So we've got through the part where we've set up our secrets. We've created our connection from Azure to GitHub so that we can actually run all this and have it access. So if you need to see how to create a key vault that we just used, you can go here in the actual workshop notes. You'll see there's a create key vault process. We give you instructions how to do it through the portal, but you can also do it through AZCLI, or you can use PowerShell, either way. And then obviously we just went through how to store your credentials as secrets. So those are the service principal information that we set up. You can get an example of what everything will look like here. And then what we did was we updated our Azure deploy.parameters.json file. That's this one right here, where we actually gave reference to the key vault, the resource group, and our subscription ID. And so we did that for the 3 different parameters we created. So SSH RSA public key, service principal client ID, and then the service principal secret. All right. So finally, the last part of this, and we're going to just take a look, is the manifests. This is the actual file that is called from our Bicep template during our deployment, or I should say our workflow file. It's called from here, and we'll talk about our workflow file now. Our workflow file goes through a series of things that eventually will be run by GitHub Actions to do our deployment. And as you can see, what we've done is we said when a push occurs to the repository, we're going to start, 1, setting our environment variables. 2, we're going to specify that we're going to be using Azure ARM, and we're going to build and deploy our application on an Ubuntu server. We're going to check out our code that we're going to be using. We're going to log into Azure, and you can see we've got this secrets environment variable that we refer to. And that's going to be the actual connection between our credential, or I should say our GitHub Actions, and Azure. Once we're done with that initial connection and we're logged in, then we're going to deploy our Bicep file, and we'll take a quick look at our Bicep template in a second. We'll set the target Azure Kubernetes service cluster, and so that's our Azure credentials where to get logged in, our cluster name that we are going to create, which is just, in this case, it's just using the name of our resource group. And then we specify what resource group we're going to create our cluster in, and it's the same environment variable. You can see we've got them all here. They're just referring back to the secrets that we've created. And then finally, what we're going to do is we're going to use kubectl to run and apply a manifest that we have here in the deployment file. I should say in the manifest directory in a deployment.yaml, and that's going to give the instructions to what kind of cluster we're going to set up. So we're going to create a 3-node Kubernetes cluster we're going to create the application, which has got the backend, our backend actual image, and you can see it's just a public Redis image. Eventually, we get down and we're going to create our front end, and same situation. We're going and we're creating it from a container that's already available. In this case, the Azure Vote Front, which is the front end, and you can see we've got our resources specified for how much CPU we need, memory. This is outside of the actual AKS cluster specs. These are just the actual amount of specs we're using within our AKS. And I'll show you how we're going to actually create our AKS with Bicep. And I know I'm going through fast because we only got a little bit of time left. And then the last part of our deployment YAML for our actions file is creating a service that is essentially a load balancer that forwards our application to port 80 right here. All right. So we've got all that ready to go. And it's all being like kicked off by our Bicep template, the actual infrastructure that we're needing. And within here, we've got some stuff. And so, Marcus, I wanted to just ask you, can you just give us a quick rundown of like what's going on right in this section around the resource creation?
Yeah, so here we're using the resource keyword. We're giving it kind of what's called a symbolic name. You can think of it like an alias, which is where we have AKS. And then we're referencing the provider, which is Microsoft.Container Service. And then we're referencing the resource type, which is managed clusters. And then there's an API version to go along with that. And there's also IntelliSense offered for that. So if that looks really super confusing, the IntelliSense can kind of guide you through. And so, yeah, and then on line 39, we're giving it a name, and for that name, we're referencing a parameter, unique cluster name. Then we're giving it a location, which is the region that it will be deployed to. And then there's a bunch of properties that are defined down below. I don't know if I need to go through each one.
No.
Yeah, if we could just go to the top really quick, we can see a whole bunch of parameters. And there's that @ symbol before them, which are called decorators. So in this case, we're setting a lot of descriptions, which is just metadata to describe what those parameters are actually doing. So they make it a lot more readable so I can understand what those parameters do.
Great. So we've got an understanding now of our Bicep template. We've got our manifest file that is going to be doing our deployment to Kubernetes. And then we've got our GitHub Actions workflow. And so to kick off this GitHub Actions workflow, you can see source control, the change that we only really needed to make was to our parameters. So you can see right here, what we typically would want to do, and we're not going to today, and I know it's bad, is we typically want to create a new branch and then commit this change to our new branch, and then have it go through a process of review from one of our peers, make sure everything looks right, and then go through the merging process. But because today we only have limited time, we're going to go ahead and push directly to the main branch. So I'm going to click here in VS Code on the source control tab, the plus, that's going to stage our changes. And then what I'm going to do is go ahead and click commit all. It's going to ask me for a commit message. And in this case, I'll just say params and deploy. And then I click sync changes. And so once those are synced back to GitHub, and let's make this nice and big so we can all see. Once this is back to GitHub, we're now going to have an action kicked off and deployed. And it's already started. So we can see here in GitHub Actions, and that's right here in the Actions tab of our repository, params and deploy. If I click that, Oh, it failed. Why did it fail? There's something wrong with my credentials. Well, I'm going to go ahead and pivot to one I've already got created. Thank you very much for living with sometimes you do it live and it acts funny. So let's go ahead and go over here. This happens, like I said, when you do it live sometimes. Let me go into it. Here we go. AKS Bicep template. Actions. All right. Well, we'll go through this and I'll find a working one. Stephen, do you want to talk about what goes on here in a failed version?
Yeah. So actually, let me just check. I might have a working one here. Let's see. Nope, I did not kick mine off locally. All right. So what we've got going on.
I'll get mine in just a second. I know I have one that's working.
So what we have going on is make this a little bigger so I can see your screen. We start with setting up the job, right? So the actions runner is going to pull down some information from the from the job dispatcher and set up environment variables. It's going to gather some information about the runner environment. It's going to download any of the actions that it needs to run your workflow. And then we start running, one of the most common first steps that we see is a checkout. And that's going to clone your repository and make sure that we've checked out the current version, depending on what's kicked off the build. If it's a pull request, it's going to check out the code for that specific pull request. If we're running off of a branch, it's going to pull whatever the head of that branch is.
I got a working one here for us.
Oh, awesome. Right. There we go. And so once we have that working, that checkout of our current branch that we're working on, we can move into the Azure login. Right, and that's where we were bumping into a credential problem before, but this makes sure that we're connected to Azure. And Jay, did you want to pick up and continue, or you want me to keep rolling through?
And so then it goes through the deployment process, and that deployment process will go ahead. It will run the Azure Arm Deploy action within our workflow file, and our action actually says we're going to specify our subscription ID, our resource group, our template, the parameters file, the cluster name, the resource group that it exists in, the namespace within Kubernetes, and our app name. Eventually, it's going to complete that. It's going to run the kube config, so our kube CTL process can happen. And what it'll do is it will go ahead and apply to that vote app prod namespace the manifest that we have. And so you can see namespace created.
So Jay, just one thing I want to mention about that context set.
Sure.
That's taking advantage of some of the overlap with the Azure Kubernetes service and the Azure CLI, and uses that to set up your kubectl command, which is a completely separate command, to be authenticated to your.
Okay. I lost Stephen got you back.
Oh, sorry. I was just saying that the AZ the set context step uses the AZ CLI to get the context information for your Kubernetes cluster. So you don't have to worry about setting up any of that authentication. That's all handled on the Azure side for you, and then makes it available to your kubectl command to then go and set up what you need to in the next steps.
Yep. So we're going to go ahead and see we've got this Kubernetes cluster that's up and running. I've got one that I already created. And what we need to do is actually log into it. And so what we can do is click the name. We'll see right here the resource group name, all the other information. I need to go ahead and get the credentials. And so I'm just going to bring up a new terminal, make it larger so you can see the process of going into kubectl. and running the command. So what I will do is go back to our template. And you're going to see at the bottom, I've got this kubectl command that is first by our get credentials process. And so this is just an Azure CLI command for the AKS service. We're going to give it our name, which is just AKS Bicep. That's the name of our resource group. Excuse me, the name of our actual cluster. Then we'll give the name of our resource group. That is AKS Bicep.
I think you're missing a dash between resource and group.
Oh, yeah, I am. There we go.
Pairing for the win.
Thank you. And so then what we'll do is it will log into Azure. Oh, go under AKS Bicep. Was not found. Let's double check the name. And like I said, it's always great when you do it live. Okay, so it's called Vote at Prod because I did this earlier. So I'm just going to change the name. Thank you all for being patient. Like I said, it's a live workshop. These things happen. And so I've got some kube configs already installed on my local machine. So I'm just going to overwrite it. And I've merged that into my kube config. And what I can do now is get my namespaces and services. And so we'll get all the services that are available. And that's where our load balancer IP can be found here in Azure Vote Front. So we can just copy our IP address. And here's our application. And so I could take that IP, I can create a DNS name for it, whatever else we need to do. So that's the gist of this. That is a run through, and I know it was a little frantic, but we only had so much time to do it. Definitely.
Oh, I think we lost Jay again. Why don't we pop back to the slide deck, and we've got some follow-on resources for everybody here.
Yep. Sorry about that. You know,
Oh,
the computer rage quit on me. All right. So we've got some closing resources. Stephen, why don't you kind of kick us off on what's next?
Yeah. So now we've gotten through the workshop. We can, if you want to follow and find some more things about DevOps, we've got the DevOps Resource Center. You can find that at aka.ms, all-things-DevOps. And there's stuff about process, there's stuff about our transformation, there's stuff about source control, agile, all the things that you care about DevOps. Great place to get started learning.
Absolutely. And of course, if you'd like to also get certified, getting started DevOps, that's an AKS link right there. Designing and implementing DevOps solutions, another great one right there that you can use. There's so much that you can learn through free learning with Microsoft, so you can get on your road to being certified. And I think, Stephen, is that it? Oh, yeah.
Oh, yep. So there's lots of other free learning resources on Microsoft Learn, including, and I saw this come up actually in one of the comments, there is a great learning path on Bicep. Actually, there's several learning paths on Bicep at Microsoft Learn. So if you want to get hands-on with Bicep, from how Bicep works to how you use it in the CI/CD environment, you're going to find resources on Microsoft Learn for that. Marcus, any final words, anything you want to share with anybody before we have to wrap up for today?
No, yeah, like Stephen said, go check out the Microsoft Learn modules on Bicep. It's a great way to get started. We can post some more links in chat as well to some of the follow-up comments here. But yeah, that's all I got.
And so, that kind of closes out this portion, our little workshop that we've done. Like I said, thank you for being patient with us. When you do it live, especially all this virtual stuff, you go through it. And that's what it is. but I'm glad we got through it. We showed you how to get all the different components created. And now we're ready to kind of learn more. And so one of the things I want you to remember about this workshop is that these were just real basic getting started things. That includes this bicep. That bicep template was very, very basic. And so you've done all this. You've worked through the process. And now, congratulations. You've earned the Builder Azure Hero Badger. So why don't you go ahead, take out your phone, take a screenshot maybe so you can get back to it, and scan that QR code. You can get your Azure Hero Badger badge as a builder. You've gone ahead, you've built something with Azure. So go ahead and click that now. And then also, you'll want to be able to go and make sure that your tree has been planted and get your sticker and certification, because you've completed this. And on your behalf, we have planted a tree because we find that we want to get more and more carbon negative, get towards net zero, if you will, so that we can protect our environment, protect this earth, because we all have to live here, you know?
Awesome.
So we're getting close to the end, and I just wanted to say thank you to everybody. Thank you, Marcus, for being part of this. You really made a lot of help come from, or I should say, you really helped me get a lot more information on Bicep, and I really appreciate your time.
Yeah. And one last thank you. So we've had a great panel of speakers. We had a great workshop. But Jay, you and Suzanne did a lot of the legwork to set all this up, to bring everybody together. So thank you for giving us this great event, helping people who are interested in DevOps find their way forward. And, and then we got this awesome hands-on opportunity to try out a number of these great capabilities. So thank you both.
Yeah, thanks. I appreciate that. Suzanne Chen was just absolutely instrumental in making this all happen. And she literally did it from the other side of the planet from where we are. You and I are in the US, and she's over, I believe, in China. And so we're talking about a huge time difference. And she came out to make sure that we were all accommodated. And that was really big. There's one person I want to thank more than anybody, and that's my buddy Abel, who I miss very much. Abel really laid the groundwork for a lot of the things that you saw here today. He worked really hard to get people to understand why DevOps is important. And I learned a lot from him, and I really do miss him. If you don't know, we lost him a few months ago, unfortunately, to illness, and it's been tough, but his legacy lives on through people who don't want to accept the defaults, that don't want to right click to deploy, that want to do all the things. They want to automate everything, and they want to make everything lean and agile. And he really set that up for a lot of us. And I know, Stephen, you really appreciated the man, and we all miss you. We all miss you. And I'm sorry to make it all kind of low there, but I really thought it was important to remind everybody of just how important Abel was to all of us here at Microsoft and across the DevOps community.
Most definitely. And I think we are now about to our time. So thank you so much. And yeah.
And if you want to keep the conversation going, go on to the Azure DevOps blog. You can just Google Azure DevOps blog, where we have tons of information. We've got the weekly roundup of news that you can find about what's going on in the Azure DevOps community. If you write something that's really interesting, we will make sure you're added and have your name, your content in that digest so that everybody can see it. But that's really it for me. Steve, thank you so much to all of our speakers. Thank you so much to Ryan, our producer. Thank you very, very much. You did a great job. To everybody, thank you so much. Have a great rest of your day and week, and take care of each other.